No, don't.
Hello. Yep, this is working. Everyone, come down. Join us. Pull up a beanbag. Drag them around.
I'll stand.
Welcome to Decompress. I'm done.
You can't drop this. We need this here. So I can.
Yeah, sure. Sorry.
It's okay.
Well, we're already behind schedule, but that's fine. We gave lots of time to the speakers. Just leave that one.
Coffee's going to be here all day, right? Maybe we should say this.
Coffee will be around all day. So, you know, you can get it later if you want. Should we just start? For 1 second. How's everyone feeling? Good? Excited? Awesome. Ready to go? Ready to go?
I think so.
Let's do it.
Let's do it.
Is everyone ready to go? All right. Welcome, everyone. Welcome to Decompress. My name's Robert, or Rob. This is Isabel.
Hi. Before we start, we want to acknowledge the custodians of the land, the Wurundjeri people of the Kulin Nation, and the elders past and present. We acknowledge and respect their continuing culture and the contribution they make to the life of this city and this region.
So we're excited to have you here today, really excited. And we want everyone to have the best experience possible, where everyone feels welcome and included. So just like the last 2 days, we operate Decompress under a code of conduct. So this is a safe place, free from harassment of any type at any time. If you have any concerns regarding the actions of attendees, speakers, staff, refer to the website that features the full code of conduct and reporting guidelines.
If you don't already know, today we're wearing different colored lanyards. There is, I think by today, there's 4 different colors. And we run out of the green and blue ones. But if you see someone with a green or blue lanyard, that means they're fine for you to take a photo and post that anywhere you like. If you see someone with a black lanyard, please ask them first before you, I don't know, like tweet a photo of them. A red lanyard means please don't take a photo of me, and we'd ask you to respect that.
So Decompress, just like JS-Conf AU and CSS-Conf AU, is run entirely by volunteers. Today, you'll find us around the venue. We're not wearing different colored shirts or anything. We're wearing these in various ways. So look for the sparkle red fabric. Hopefully, we're easy to find. And please approach us about anything, any questions you have, any concerns. If you want to know where the toilets are, anything like that. Yeah, if there's an overflowing bin, tell us to empty it. All right, we'd also like to give a shout out to our sponsors who have made all of this possible and who you'll see come up here. So they've made sure the coffee, the food, all of the excellent speakers we've been able to bring to you. So these are Mozilla and Adobe, Summer Snow, who have been providing the juice, and then our travel and workshop sponsors, Data61 CSRO, Dev Diner, Holla, Solnet, and TalkBox.
So this is the 3rd time that Decompress is running in Melbourne. 3 years ago, Decompress was started by Mark, who should be around somewhere.
You're around,
Mark, are you here? Okay. He's wearing red too, I think.
A lot of you may know Mark.
A lot of you may know Mark. Mark, if you hear us, we're very, very thankful that you created this conference, the atmosphere that makes up Decompress and the whole vibe.
So if you've been to Decompress before, you may have noticed that this year we're running things a little bit differently. But keeping in the spirit of Decompress, we've tried to make this an affordable, inclusive, community-driven event.
So last year, for me personally, was the first time that I've went to, I think, any tech conference, and so I went to CSS Conf AU, and I was lucky enough to get a ticket through the diversity program that they ran. I didn't really know what to expect. I was very new to web development myself, but I was amazed by how accessible the talks were, how good the food was, and how welcoming all the attendees were. But one thing in specific blew my mind, and that was that throughout the day there was speakers and organizers that would take time out of their day and their busy schedule and show me, who was new to this, the tools that they loved, and gave me a kickstart. And I learned SAS and, I don't know, all sorts of things that I use now. So when it came up to Rob and myself to organize today, we wanted each of our attendees to have the same fuzzy and welcoming feeling.
And we found some brilliant people who agreed to help out with that by running informal workshop sessions throughout the day. So the first thing we're going to do today is have them introduce themselves and tell you about the things they've been working on.
But we also like to ask your help to shape the experience of the people around you. So today we have printed some stickers. They might be a little bit hard to see. They look like this. These stickers basically name the tools that you're happy to help out with. So we would like to get all of you talking and help each other out with all the tools that people want to learn. We'll be handing these out shortly, and if we could just ask you if you're happy to be approached to stick them on your shirt, probably in order of how comfortable you are with a tool, just a row of stickers. And we'll hand them out shortly just after this.
Yeah, so those are CSS and JavaScript, sort of just general help, as well as, what have we got, Node, D3, WebVR, WebGL, WebAudio, Cordova. So basically, if you can help anyone with any of those, even across all of the workshops, that would be awesome.
Even just a little bit.
Even just a little bit. Even just moral support.
Holding hands.
So we're up there. So the workshops, well, we're calling them workshops, but it's really more like that end of the hall is a hack day. The workshops are more like themes or vague areas or topics. So they're going to run all day down the other end of the room. There's desks out. There's going to be the people presenting this morning. Some of them will have screens that they'll be showing some of their work throughout the day. We want you to ask them to get an idea for something you should work on, or if you have your own idea, start working on it, and ask the people around you for help, people with the stickers, the workshop people themselves who are going to be running this morning. And in parallel, in this room, throughout the day, we're going to have 10 talks going on. So 10 fantastic talks.
These are all talks that could have easily been happening throughout the last 2 days if we had had more space for that. Also, one thing that's new to strengthen and enrich the community in Melbourne, the local tech community, we invited some of the fabulous people who run local meetups to be around and chat to people over lunch. And we'll make sure that they're visible, and they will be just in this beanbag space behind you. Please go talk to them, they're all super nice. One other thing, we put up a little poster on the side of the big doorway. If you know of a meetup, or you're running a meetup, or if you, I don't know, if you just heard of a meetup, feel free to just write it on there. We'll provide some pens, which we haven't done yet. Just write where people can find it, and so, I don't know, at the end of the day, you can take a snapshot and find all the beautiful meetups that are happening around Melbourne. Oh, sorry. So, one other thing that's, as we said, what's important to us is that everyone feels included. And so please don't treat today just as a conference, but maybe more like a camp, like a community event. So every once in a while, look up, have a look around, and maybe try and find someone to talk to. Try find someone who doesn't exactly look like you. If you have trouble finding someone who doesn't look like you, that's even more important. And try and approach them and find out what they're doing here, what they get excited about.
Make them feel welcome. And now we're ready to go. So bathrooms are in the room behind you, that space to the right. There should be signs. And if you'd like to smoke, please do so in the garden out the back. We'll also have lunch out there in the car park. So the same sort of alleyway that you get to the toilets. If you keep going forward there should be some stairs and a car park out there. We'll have 2 food trucks set up.
If you don't want to take stairs, find a volunteer. We can open doors and get you through around the building.
Yeah. And if you want to share what you've learned, share photos, impressions, helpful links, thoughts.
Love.
All of it. Our hashtag is Decompress16. You might have seen it rolling around. And yeah, welcome everyone. So before the talks will start at 11. We're doing workshop introductions. So the 4 workshops that are starting now, starting at 11, we're going to get one person from each of them up to tell you a bit about what they do, get you excited, give you some inspiration. And so first up for that, we have Charlie. Charlie has come all the way from London today. Charlie is a triple threat. He's a designer, a programmer, and a musician. And today he's going to be talking to you about WebGL and video and shaders. And I'm really excited. All right, Charlie.
I'm just going to move this up slightly because I'm the tallest person on Earth. Cool. Sweet. Awesome. See, we're golden. I can't get this wrong. I'm going to lean very awkwardly. Actually, maybe I can move this and just kind of we'll just get real personal. Hey. I'm just going to take 5 minutes to talk a little bit about me and why I'm here and what I do. I called the talk Don't Panic primarily for myself because I don't really know what I'm doing with my life. But I'm a designer, developer, and a computer science dropout, and I work primarily as a front-end architect, though I originally studied design. And my passion is creating seamless, interactive things. But before I get onto that, I have 2 things I realized between when I started doing this and now. Learning new skills is really hard, and putting them into practice is even harder. So with that in mind, my advice today is to build one thing, and while you do it, talk to people, experiment with code, embrace messiness. It doesn't really matter if there's spaghetti behind the scenes, if that side of it looks good. It just matters if you're enjoying the process, because if you're enjoying it, you'll do it tomorrow, and then the day after that, and then the day after that, and then you'll be Mark Zuckerberg. So it's a slippery slope, but you'll be fine. To give some context on me, when I'm not making small bits of the internet, I'm a musician. I started a band in 2011 or so called Brightly. And being a musician means spending long stretches of time working on pieces of music with no assurances that anyone will actually care when you put them out. So you fill the time in between doing things like this, or getting stuff thrown at you, or standing in a blanket in a creek in suburban Melbourne, or pretending to hide in a bush. Be the bush. You are the bush. You damn artist. So once we finished this album, of which there's been a few now, we tried to make music videos. And music videos cost a lot more money than taking cool photos in cool places looking like a cool genius. And after we spent a couple of $1,000s on a music video that was truly horrific, I figured as a web developer I should probably try and build something. And I've been doing that for a little while because when I get frustrated or excited or emotional about things, I tend to make websites about them. and they're usually really small, ridiculous things. But the most important thing about it is learn a new tool because it helps you make something. So I don't really make things because I want to learn a new tool. I learn a new tool because it helps me to make things. So I thought I'd give some examples, some context, get you inspired. I feel like we're doing well. This is such an awkward position to stand in, by the way. I'm like, you guys, so you. So I'm engaged to a really great guy, but I can't marry him here. So I listed, when the Senate had the opportunity to vote on marriage equality, it gets less political, don't worry. When they had the opportunity, a lot of people voted against it, and I really wanted a way to name and shame them. And so I learned the screen scraper Nokugiri, which I'm going to pronounce wrong. I read Wire's Poignant Guide to Ruby, and I felt really invincible. I also made it into the smallest pocket of the gay press, right alongside an article about a serious and concerning rise in sexually transmitted infections. So that was good. My friends and I really like Arrested Development, so we made an Arrested Development auto-magical episode chooser. For obvious reasons, we did not include season 4. I learned Angular, I learned JSON, I learned how difficult it is to programmatically play a GIF once only, and I think it actually led Glenn, one of the organizers of CSS and JSConf, to build XGIF, which you should 100% check out. I can get really quiet because I'm so close to the mic. I was 1/3 of the social film site Good Films, and I wanted a way to whinge about things without having to do much more than send someone a URL, so I built No, 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 No. A website you feed a subdomain to so that Michael Scott can yell no at it. It's really soothing. I'll show you a couple of these really quickly after I go through them. I learned Flexbox, how to manage wildcard subdomains with Sinatra, and how to deploy to Heroku. While we were sharing a big loft space in Melbourne in the Moran and Cato building, I started Moran and Cato, which is a really, really, really short-lived music video project aimed at recording indie artists. I learned CSS animations and how consuming video editing is. And then music, I built beginnings and endings because it's technically a pyramid scheme, but without the financial ruin. It tracked a song shared from one person to another person, measuring the distance as it went. If 10 people share it down the tree from you, you get the album for free, and it made it over, I think, 1 million kilometers in the time that people were checking it out. I learnt Rails, how to send emails, and how to build a community around an idea. I really like cats. That's clearly obvious. When I was in Istanbul, I saw a ton of them, and I love them, so actually both my son and my daughter are cats. I tagged the location of each one I photographed and built a site to catalog them, so if I ever went back, I could find them again. I learned about visualizing locations, optimizing big images, and how to stop a cat from running away when you're trying to photograph it. And then I made Tweetflight, which took everything I'd learned and smashed it together in a perfect storm of something that was temporarily dizzyingly viral. It searches Twitter in real time for lyrics from this song and plays them back like some kind of feelings karaoke. It's a simple concept, but it was built on top of those tons of tiny little things that I learned one by one. And I learned a ton of stuff about memcache, video, CDNs, and how to answer weird questions on Reddit. And from there, I built a ton of music videos and music-related projects like True, which uses the Web Audio API, Anatole, which uses 3JS, Rugby, which creates a video in real time using GIFs with trending topics, and I'll Never Let You Go, which is how I got onto my talk today. Basically, I'll Never Let You Go surreptitiously takes photos of people watching the video and plays it back to them each time, so it's like everyone watching everyone in a big, creepy hangout. They give permission for the photo to be used in the end. It's not like I just do it and keep them. And weirdly, lots of people did submit themselves in various states of watching and looking uncomfortable with just how much makeup I was wearing. So I built some things, big deal. The point of this wasn't for you to relive my CV in dizzyingly painful detail. But the point is, no matter what you make, you're learning something, and step by step, when you start to bash all those things together, you get something greater than the sum of its parts. So do that. It's microtransactions for the soul, really. So today I'm going to be up the very back working on 3JS. I built a boilerplate, and it uses Create React App as a backbone, so you get Webpack and ES6 out of the box. But if you don't know what either of those things are, it's cool. You don't really need to. Basically, it has a series of playgrounds you can start to mess with, as well as some pre-composed shaders. So I'll really quickly give you the URL. It's tinyurl.com/r3playground. You can also find it via my GitHub, super high fives. And now I will try very hard to jump over to it. So this can be really hard to edit, but basically all you do is change out your playgrounds in the top left here. It's so tiny you definitely won't be able to see it. But the README goes through in great detail all the different things that you can do to try and mix it up. So if you, trying to do this while looking really close to the microphone. If you see over here, React 3 Playground, it's got a ton of helpers, shaders. You can feed it everything from videos to GIFs to your webcam. That was me last night. You can pass through multiple shaders, all that kind of stuff. So please come hang out with me. I won't talk to you as close as it feels like I'm talking to you now. And thank you very much for having us.
I also happen to know that Charlie made all of these things, I think, in the past 4 days to prepare for you, which is amazing. I would like to introduce you to one of my favorite people, Ree is, you look surprised. Ree is a data visualizer, and she shares my love for data and also art, and she's trying to combine those two. And she's gonna run a D3 data workshop today for you. Ree is currently working at The Guardian, so every time you see some amazing interactive data visualization in The Guardian, that's probably got Ree's name underneath. Sometimes. Every time I check. Please welcome Ree.
All right, hello everyone. I don't have slides, but I realized looking at Charlie's beautiful deck that I should probably put my name and like Twitter stuff, so I've got that up. In Sketch, I literally did this as he was speaking, so this is as live as you're going to get. No, I do have some live demos a little bit later, which will probably break and freak out, but that's fine. So yes, I'm Ree. I specialize in data visualization, and at The Guardian, I create interactive stories, sometimes with data, sometimes without. So I work with journalists and, you know, we work on our own features that we come up with out of our brains, or working with journalists on their stories and what's going on at the moment. So I'll talk a little bit about that. The workshop today is going to be very informal. I haven't really prepared any technical stuff, but my idea is that you'll come in with something you want to work on, whether it's big or small. So small could be maybe you just want to play around with D3. So I'll provide a link with some good starting points if you're there. You want to. Isabel actually created a wonderful tutorial for beginners to learn D3, so that's probably a good starting point as well if you're in that space. Or if you've got a big data project and you just want to play with it, you've got a theme you want to tackle, come to my section over there. But also hearing Charlie's talk, I realized there's actually a lot of cross-pollination with a lot of the things, and the WebVR one as well. And so I might actually, I'm kind of a little bit jealous that I have to run the sad that I have to run the workshop and not attend those workshops, because I really want to play around with 3JS and VR and all that. So you won't hurt my feelings if you want to just dart around and check out the different stuff either, because it's awesome, and I would do the same if I were you. So I'm just going to start off by quickly just showing you a little bit some of the stuff I've done. So we had the election earlier this year, and so me and Nick Evershed, who's the data editor, built this results page, and so this uses D3, and it kind of shows you everything. So one interesting thing I want to point to, a challenge with this was playing around with mapping. So mapping is a component of D3, and I was excited to kind of get to play with making my own map. So yeah, I got to create this map for the election, because we have this unfortunate thing in Australia and a lot of other major cities where the cities are very densely populated, but there's a lot of space out there that is not, and the electoral map is designed around population density. So I designed this map custom to solve that design problem. And so you can see the little green that is Melbourne, because we're the only green electorate. And so if you were to see that in an actual map, you wouldn't even be a dot. It would probably be less than a pixel, because Melbourne is so tiny compared to this whole Northern Territory electorate. So that's some of the stuff I work on. One of the other projects I worked on earlier this year was Nauru files. Quite a sensitive topic, dealing with abuse on Nauru to asylum seekers. And so there was a leak of a few thousand files. Oh, and it's slightly broken. And I worked on trying to visualize that data, but also with the constraint that it's quite an emotional, sensitive topic. So trying to figure out how you get people to engage and interact with that data, and also give respect to the people involved, and to give them a voice even though they are anonymous. So there was that project. And another one I did, it was another interactive looking at the diversity of the new government. So this was post the election, so I did the election results, and then post-election I looked at the data set of the elected peoples, and you can kind of filter in all your demographics, and you can kind of see, and most of the time you end up with people that aren't really like you. So we don't have a very diverse government. So I think if I do 35 to 64, we've got a lot of old dudes in government. So yeah, so that was another project. And then, so that's some of the stuff I work on my day job. I also like playing with data in my spare time, so I thought I'd walk through a little bit more about the process I take with tackling a data project. And so I'm very prepared. I'm using Finder and Sketch and everything on the fly. Let's see. So I did a project a couple of years ago where the UN Human Development Organization put a shout out to see what data visualizations people can come with out of their human development report. And so this is example of a data set I'll work with in one of my projects. And so I decided to kind of go and just specifically look at the data around gender, because it's something that I personally quite care about, and usually that's how these projects start for me. Like, there's an issue or topic that comes up and I really am not happy about it and I want to do something about it, and I tap into that emotion. So I was like, let's look at what's going on with gender. What are the gaps between countries? And so usually how I start is I'll kind of sketch out a bunch of different ideas, but first I'll usually just plot it out. So this is kind of just a basic line graph of all the countries. The blue line is the men, the red line is the woman, and I'm just kind of seeing, I don't even know what this is. This might be secondary education gaps. So this kind of is the first step for me for any data project. It's just to see the data in a very rough form, and then just to see what stories could be told, what you want to, what I might want to highlight, what dimensions maybe you want to rearrange it somehow. And then from there, I'll kind of look around and see what other people have done, see if there's any visual inspiration out there, and come up with like a few starter sketches. So I will use a pen and paper for this step, but I'll also prototype in D3. So I think I've included some of the prototypes further down. So that was one, kind of boring. You don't really know what's going on there. There's a mess of lines. This one was interesting. It was kind of just showing like who has the biggest gap and right down to the bottom. There was another one playing around with like the gap idea. And then this was an interesting one that I tried. It was very abstract, like, and the form looked interesting, but I didn't quite get the feel of the data. Was there any more? Oh, this is not. This is a little bit closer to what I ended up doing. So I will show you what the final result is. So this is what I ended up creating. And it did end up being one of the finalists for this competition, and I was lucky enough to get sent over to Colombia to talk about it, which was quite exciting. And so this was essentially looks at all the different dimensions featured in the data set. So labor force participation, education, parliament, income levels, and so essentially you can choose to look at each theme and then see how the countries are ranked for a specific year. So you can change the year. It might be a bit sluggish. Oh, maybe it didn't change. I think it changed, but none of the data is the same, so you won't see anything. You can sort it by, who has the smallest gap between men and women, and to see that. The most interesting one for me to look at is parliamentary participation. And so these are the countries that are the most equal. Yeah, so the one that is always interesting to me is to sort by the countries with the most women in government. And if you kind of scroll down, where's Australia? We're not really featured. Let's see. Every time it's a heartbreaking thing. 52. 73%, we are on par with Iraq. So, congratulations to us. Anyway, so that's something that was interesting, just to see where countries sit and what your expectations are. And that's the thing that is really enjoyable with working, with visualizing data, is to get these types of insights and to be able to explore and create your own stories from what's going on. So what was striking to me was that the number 1 and number 2 is Rwanda and Bolivia, and they have 64% and 53%. And I decided to do some research to see what's going on. And I'm pretty sure both countries, Rwanda definitely have a history of recent genocide, which isn't so fun. But what the government did in reaction to that, because the male population as a result was severely decreased, they decided to instate quotas to encourage more women to run for elections. And you can see Rwanda has completely flipped, and Bolivia in the recent years. And yeah, it's quite fascinating to see that reflected, that actual flipping of the colors. The blue is now on the bottom, the green is now on the top, to see that happen. So that's that project, and so maybe at the workshop you might want to follow through a different journey with another topic to play around and sketch with some data sets. The other thing I wanted to show you was I also did a project where I participated in something called a choreographic coding lab, and so got sent out to this massive. There's a lab space in Deakin. That's like, I think, the biggest motion capture space in the Southern Hemisphere, or some braggy stuff like that. We were essentially, the participants were essentially given a set of 3D motion captured dance data. And I decided to play around with that. And so there were a lot of kind of motion graphics 3D people, but I usually work in the web, boring 2D space. So I wasn't quite sure what I could make with it. So I decided just to do what I usually do, like follow the process I usually follow with data projects, and just view it as numbers and data, and see what interesting insights and things I could come up with. And so the first iteration for this project, this is going to be a video of the first sketch. And so I just decided to draw out isolate specific body parts of the dancer, And unfortunately, the lines are going to look really fuzzy and faint, but I promise you it looks amazing on my screen. But this, every time I present this, I always forget that the contrast is terrible, and hopefully in the next one you'll be able to get an idea. But essentially I've isolated the head and the two hands to sort of create this painting of the movement. And this is made using D3, and it's very inefficient, but for prototyping, I got to see the data being played out. And so I decided to look at maybe the speed, and so the next iteration, I toggled the thickness of the line depending, so there are a gazillion circles being drawn, so I toggled the size of the circle depending on the speed of the movement. So just figuring out, from one frame to another, which one has what has a bigger distance, and draw that as a bigger circle. And it came out as really beautiful, smooth brush strokes, and I was like, oh, this is kind of cool. And then I decided to play with something else and look at, I think this is the relationships between parts of the body to see if you can make something out of that. And so this is connecting the left hand and the right foot, and the right hand and the left foot, and it kind of created this ribbony effect. And so, yeah, it was a really interesting project to try and create, dance is already an art form, maybe another type of art form with that data. And so, that was the first one, but you can kind of see the lines a little bit better there. Okay, here's a live demo part, so that might fail flat on its face. So I created, so I wanted to show you this tool, which is what I used for all the dance moves. And so this loads in the data and uses D3 to draw out all these lines, and you can kind of toggle between all the different representations. And so there's a few different files here. And so at the end of the lab, this is kind of where I got all the data files with all the dance data and then the different representations. And so what I really want to do, the missing gap, was moving out of the 2D space into 3D. So I just wanted to show you that something I'm working on based on this data, which is it rebuilt in WebGL 3.js. And I haven't quite got the panning right, so if someone can help me out with that, that'll be great. And also, to get this in VR would be really cool. So whoever's doing the VR stuff, we can cross-pollinate this and just go around. And so yeah, this is kind of what I'm looking at and working on. So hopefully that gets you excited and gets you some ideas. So yeah, definitely come and hang out with me, learn D3. Let's chat and let's play with data. That's it. Thanks.
The next person I'd like to introduce you to, I've personally just met, and I think that means a lot. That says a lot, because I didn't know you before, and yet you're still here and willing to share all your knowledge with these people. Tommy is, in his own words, an aging punk developer. He's working for Adobe, who also provided the coffee. So we've got two things to thank Adobe for now. And he'll be showing you how to work with Cordova, using his background as a 6-year developer for PhoneGap.
Is it all good? I'm just trying to look for the sound one now. I can't find the sound one. I don't think it matters, actually. I'll skip the sound. It sounds like too much trouble.
You want to plug in audio?
Yeah, I don't know where it went.
You got it?
Sorry.
It is, it's down there.
Okay. Might or might not be a good idea, as it turns out. We'll see.
You might want to check that it's back on your headphone output.
Oh, yeah, good call. One moment. Yes, good, excellent. That's what we like to see. Oh, now everything's gone weird. There we go. Now is it going back to, woo, there we go. Hello. All right, so I'm here to talk about building mobile apps using web tech, right? Apache Cordova, PhoneGap, whatever you might have heard of before or what you might know about it. Yeah, I'm trying to get people excited about the idea of still using the tools they know and the languages they know from web development and using them to build mobile apps that are actually, deployed to app stores. Whatever we think of those app stores, whether we think they're a good idea or not. Personally, I'm an advocate for the open web, and I think that, all this stuff is hopefully just a polyfill, and hopefully one day I'll have to find a new career. But until then, app stores are a thing, and as long as app stores are a thing, you might want to create apps for them, and you might want to use the tools you already know rather than having to learn a new language or to have to, hire another team, right? So that's the point of this workshop is just, get you maybe building apps using the technology you know already from building for the web. My name is Tommy Carlos Williams. I'm probably better known as DevGeeks almost everywhere. It's too long a story to tell, but that's how you would get in contact with me if you weren't going to come up and poke me in person here. I've been a developer I've been developing for the web since 1997, but I've been developing phone applications using PhoneGap and Cordova and that stuff for about 5 or 6 years now. And I got really excited about mobile development when I got my first iPhone, and I learned Objective-C, trudged out, got a book, got all excited, learned Objective-C, and it was fun, but because it wasn't what I did for my day job, a couple months later I'd come back, and everything had changed out from under me. I mean, in JavaScript we all know what that feels like now, but at the time that was quite distressing. It was like I felt like I had to relearn it every time I came back to it. And even though JavaScript does change every 5 minutes now, I think we can all agree that if it's something that we're already doing, we already have to keep up with, then keeping up with that and not keeping up with both other things is probably a plus. So that's where my frustration led to me finding about PhoneGap before it was even owned by Adobe. It was still made by a small startup in Vancouver. I'll get to all that anyway in a minute. But probably the biggest problem is that the talk title is probably a little bit deceptive. And I think some of the messaging around PhoneGap and Cordova is a little bit deceptive because I think a lot of people think that they can just take a web app and wrap it up into an app. And unfortunately, that's not true. Or if you do that, you'll get a pretty substandard experience. The reality is you're making apps using the tools you already know and the languages you already know, but in a slightly different way to some degree. It's a lot like Electron, if you saw the Electron talk yesterday. It's a lot like that. It's statically served HTML, CSS, and JavaScript. It's not running from a server. You're not running PHP or MySQL in the background or anything. And often single-page apps, and they're thrown up onto this web view without a Chrome, just full page on the screen of the device. Now, even that's probably a little bit deceptive. It's probably more like building mobile apps using stuff that is similar to what you already know, because mobile has its own challenges. And in a lot of cases, you're not just building using the APIs you know, because a lot of those APIs aren't available on mobile at all, or if they are, they're only available on some platforms, not all platforms. So, yeah, your mileage may vary. But what it comes down to is that you're using JavaScript, CSS, and HTML, and you're able to then build apps using those technologies. And then what Cordova provides you is a wrapper for that to a native application, but it also allows you to then poke through to native functionality like device APIs, like the camera or geolocation or capturing media, things that might not be available on some platforms or others. So that's what a hybrid app is. It's basically just a wrapped web view, full screen web view, with the ability to poke through to the native device and to call native APIs from JavaScript. So that's what Apache Cordova is. I pretty much covered that, I think. Even covered that. Look at that, I'm behind. So this is the bridge. This is the bit that I think some people lose focus on when they talk about Cordova and PhoneGap. They talk about, they built the web page, they wrapped it up, whatever. It was substandard, or they didn't like it, or what's the point? Why not just put it on the web? But the exciting thing is when you're able to use both, the hybrid part of hybrid apps, when you're actually able to use the device APIs of the actual device, file storage, like I said, the camera, or even anything up to virtual reality or augmented reality, and do that stuff using an app that you built with JavaScript and CSS and HTML. The other thing Cordova is obviously it's a set of tooling to try to help do that. I mean, you could do that on your own. A lot of companies do. A lot of famous apps are actually web views that you might not even realize are web views, but they built their own bridge. They built their own, web view wrapper. Gmail is a classic example. And so what is PhoneGap then in relation to that? When you see the sign in front of the coffee, and I talk about PhoneGap and Cordova like they're interchangeable. Certainly in the past, PhoneGap has been synonymous with Cordova. It was originally called PhoneGap when a small company in Vancouver made the technology. When they were bought by Adobe, the source, the actual open source project of PhoneGap was handed over to the Apache Foundation for stewardship and has been called Cordova ever since then. Adobe only owns the rights to the name, and they got the people. So PhoneGap used to be described, I think, probably as like Blink to Chrome, It was like a distribution, like almost a commercial distribution of Cordova. But that's becoming less and less true to the point where I think probably by the middle of next year that won't be true at all. And I think that would be completely false. I think it comes down to the Adobe team are one of the primary contributors to the open source project because they are the original people who made it in the first place. So there's been other teams from other companies like Microsoft and Google and IBM who've contributed to Apache Cordova, but right now, certainly the primary contributors are still those Adobe employees who were bought in the buyout. But I think more and more, PhoneGap is becoming just a bunch of value-added developer experience tooling to help writing Cordova apps. I think we're trying to see more and more of a gap between PhoneGap and Cordova, where PhoneGap is literally just filling in some pieces that maybe we think will help you build a Cordova app, but really you're building a Cordova app, and we're not trying to pretend you're not. We're not trying to pretend that it's actually a PhoneGap app and that's somewhere special or more betterer than a Cordova app. It's literally just tooling and some extra special stuff that might help you do that, including things like, just literally a CLI that we think adds some value, or apps on your phone that help you view your app without having to worry about certificates and plugging in USB cables and so on. And we do also have, the only thing that we have that isn't open source or free is a cloud build service. So there's also, if you don't have a Mac at all and you want to be able to build for iOS, you can build it on the cloud and just get an IPA or something. But that's not the core of what we do, really. So that out of the way, I wanted to see it in action, just to give you an example. It's more about demos, I think, for me than anything else. At its heart, a Cordova app is basically just a web app. That contrast is fun, isn't it? So this is just a little app. It lets you search the Spotify API, right? So you could search Spotify API, get back a result. It's a mobile app, and you can. Punk rock, love it. So, and you can store, favorites and have a favorite track that you might want to play back later, But this is just an example app, so it's only using the free Spotify API, so it's only small bits. But it's just an example, right? So here's a web app. You can see the inspector over on the side here. It's just a normal HTML JavaScript app that happens to be using, in this case, the audio API and to play back those things. So you can use the tooling that you know to do your development. And so I think that's impressive. At its heart, it really is just a web app. But where it really shines is when it gets onto a device. So this is that same app now running on my phone. And it's, again, this is a full app that you could, oops, I can't spell the name of my own band. That you could then, you know, could be sent to an app store. Yeah, I think that's enough. So, and again, you can save favorites to your thing and come back to them later, and it's offline because it's local storage. But of course, this being connected to the Spotify API, that's not very offline. But the thing is, nearly anything that you can do in a mobile browser, and that's the catch, a mobile browser, but anything you can do in a mobile browser, you could probably send to a Cordova app. This is another variation, like a very simplified variation of it, using React. So this is just using React and custom CSS. It's not using any kind of framework or anything. It's just whipped up with React and some CSS, and it just is what it is. And sorry. Whoop. There we go. And then just to tie into some of the stuff we saw in the last couple of days, because it's really fun, you can also do WebVR. Where's my square? Oh, there's my square. Pretty. So yeah. So this is using WebVR and the WebVR polyfill, because of course, you know, iOS, which uses WebGL. But yeah, so then you get this device. This is just using the WebVR boilerplate. Yeah, that's kind of fun too. So when I talked about those device APIs, that's where it gets really exciting, right? Because if you're just using pure web and pure JavaScript and HTML, you have to ask yourself, why are you making an app? Why aren't you just making a web page, right? That's mobile friendly. So where it gets exciting is when you get to push through to the device in ways that increasingly are becoming available to developers. You know, geolocation, for instance, is available on nearly every reasonable phone now through the browser. But not every browser will allow you to record media. Or not every mobile browser will allow you to record media. And not every mobile browser will allow you to reach into the file and have file access, or record sound, or even get hold of the battery status. So not only are there a large a plethora of core plugins made by Apache Cordova team to do some of the obvious things that most people want to do, but there's a huge third-party ecosystem on NPM of various plugins, everything from augmented reality to certification, HTTPS cert, HTTPS cert pinning for security and privacy. So that's where it gets exciting, I think, for me, is that when you can actually blend as much as you can between the native aspects and the web aspects. And I think the more you push that, the more you're going to get out of it, obviously. But of course, the farther you push with that yourself, if you're not using someone else's libraries, then you're going to have to know at least enough Objective-C or Java to be dangerous. So basically, the point of my pitch is come and see what you think, even if you fall into the category of, I heard PhoneGap sucked, or I heard that it was slow, or I heard that it was, it killed babies. Come and have a look, chat to me, let me show you some things, let me see if you think it's still true, because I think a lot of that stuff stems from people who maybe tried it 2 or 3 years ago, and we all know that JavaScript is exactly the same as it was 3 years ago. So there's no chance that it could be different, right? So come and see me, see what you think about some of the things we might have done that made it more interesting to use or made it less of a pain, because I know some of the tooling probably was a little bit flaky in the past couple of years. So if you're excited about making mobile apps, you know how to make things with JavaScript and HTML and CSS, come and see me. Let's see if we can do the same thing together. Thanks.
All right. Time for the very last workshop presentation for the morning. We'll have one more in the afternoon. But right now, I'd like to bring up Pat, or Pat Cat, as he likes to be known. He's going to be doing the WebVR workshop today. He's driven down all the way from Sydney to do this with his fiancée, Mary. They've brought a whole bunch of gear. They've got a Vive. They've got some gears, some other things. And he's been sponsored by his company, or his own company, DevDiner, to do this. So, yeah, please welcome Pat Cat to the stage.
Thank you. Hey guys and girls. It's already almost 11, so I'm going to try and be super quick because you guys all want to get to things. How many people here have tried VR so far? Just raise your hands. Excellent. What have you guys tried? How many people have just tried a Google Cardboard in a day? Excellent. How many people have tried the Vive before? Cool. I like this group. How many of you who've tried the Vive are from Melbourne? Just like as a... Yeah, so Melbournians are a bit more up with things, it seems. Yeah, in Sydney, there's a lot of people who've tried the Vive and stuff, but it's less developers and more like the marketing people and all that stuff. Let's see whether a laptop wants to work. There we go. Cool. So, I'm here today to show you guys all what you can do with WebVR stuff. It's been mentioned a few times already. How many people have tried WebVR so far? Excellent. I hope to increase that number by like a lot by the end. If anybody wants to tweet at me later, if you don't get a chance to get to the workshop or you've got a question and you don't really want to come up in person, that's totally fine. My Twitter is @thatpatrickguy. You can also find my email in various places. I'm easy to get a hold of, so feel free to say hi. Basically, I'm here today and pretty much every day of my life right now doing this DevDiner thing, trying to encourage all of you developers to get into emerging tech, because it is fun. So things like virtual reality, artificial intelligence, Internet of Things, and connected devices like Arduinos, these are all things that you can actually do. And that's kind of why I travel around and tell people that you really should do it. It is good. Virtual reality is especially fun, and that's why I'm here. I'm here to tell you to join the workshop. We have headsets, so I do have the Vive that's set up. I've also got a Gear VR headset, a bunch of Google Cardboard headsets, including a really, really compact one that kind of folds up so it can fit in your pocket. So if you're keen to see those things, I've got them. I've got a Viewmaster for the kids. Or real-life large kids. And I'm here to tell you that VR is actually here to stay, I hope. But the one thing that is a really good sign, at least, is that just the first half of 2016 brought in $1.3 billion into the VR space. There are so many companies right now that are tunneling so much money into this because they see it as at least one step in the way that our interfaces in computing are going to go. It's one step before augmented reality and that stuff, which is a topic for another day. Why VR is exciting is because you can create an entire world from your imagination. So all of you right now, as web developers and mobile app builders and all of that sort of thing, you've built things for a single screen that you can look at on a phone or a tablet or a computer. But you haven't built for something where you can literally immerse somebody in what you've built, where you can create an entire world for somebody to go and explore. And the thing that is really cool about this is that you can take the laws of physics or any other thing that you think is stupid and change them and mess with people's heads in a good way, please. There is also a lot of, I'd say ethics and doing the right thing, I guess. You can theoretically scar somebody for life in VR if you wanted to, and a lot of people will probably make some wonderful horror games. But you can also really show somebody your ideas. So just like with the data visualization that you were saying earlier, you could take that data, put it into VR, and really show somebody what you want them to see. You can step them through a narrative and get them to be in the place, see this data, or see what it's like to be in a different country, or see what it's like to be in a world that never existed before. But you can do all that with JavaScript. And that's one thing which a lot of people don't realize is how powerful JavaScript and the browser is. We've got really talented people at Chrome and Firefox, and now at Oculus, and Samsung, who are all working to make browsers work with JavaScript, so you can do all this just in the browser using stuff that you guys already know how to do, majority of you at least. How many people here know JavaScript? Excellent. This is the most I've ever gotten because I am clearly at a post-JSConf event. So if you're a web developer, you can build web VR experiences. If you're not great at JavaScript, so if you raise your hand kind of tentatively, and you're like, I hope he doesn't actually test me on this because my JavaScript sucks, that's fine. You can still build web VR stuff. It is actually really easy. I've gotten people who don't know JavaScript to build web VR stuff. So it isn't actually that technical. It can get technical if you start to do really cool stuff, but you can kind of get by with the basics. So why is web VR wonderful? Well, you can use all the skills you already have. That's why I liked it. I've been a web developer for ages, and even though I've kind of branched out and done a whole bunch of other stuff, it's still my main kind of competency. So being able to use web VR is actually a lot of fun. I can code up stuff really, really quickly. Yeah, don't worry if you're not good at JavaScript. One of the things that really works is no app install. So a lot of web guys and girls, you guys already know that this is a thing. A lot of people hate installing apps. Or if it's something that is new, like virtual reality, it is really hard to be like, sure, hey, download this 200 meg app and trust it's going to be good. Most people look at that and say, whatever, and we'll continue on with life. So a lot of clients right now and companies, they're not interested in that because they don't think that'll work. Whereas with web VR, you can just direct them to a URL and say, hey, go to this URL, put your phone into your Google Cardboard headset, or plug in your Vive if, for whatever reason, you're managing to have a Vive, and you can just run through an experience. It's also good because you don't have to deal with all the app stores, and they're fun. You can distribute content directly to your audience, so you don't have to go through anybody. You can literally, even right now while testing today, you can say, hey, friend over there on the other side of the room, go to this URL and try my thing. The also wonderful thing is it is headset agnostic. And what I mean by that is that you can build something that will work on Google Cardboard, that will also work on a Gear VR, that can also work on an Oculus and a Vive without too much additional work. Whereas building for that using Unity and Unreal Engine, you can still do it, but it is a lot more effort than it is in web VR at the moment. OK, there are a whole bunch of things you can do to get into web VR. You can start doing WebGL coding from scratch. How many people here are really good at WebGL coding from scratch? Awesome. So you, sir, can do it from scratch if you'd like. I'm actually envious of your abilities. But yeah, most of us won't, just because for me personally, it blows my mind. You can do 3JS and hooking into the device orientation event. There is an easy way. How many people know 3JS here? Slightly more, but still not many. And that is fine. A-frame is my favorite thing. How many people have heard of A-frame so far? Awesome. This is where you get to use web components to put together a VR experience using what is literally just like HTML to structure your stuff and put in a lot of the functionality using JavaScript. How many people have heard of Primrose? Excellent. So I get to teach everybody about one thing. Primrose is a really cool framework for real-time collaborative stuff. So one of the really cool things that the guy who made Primrose did is he built a web app where you could go into VR and then code for your environment within VR. So you can code for VR in VR. It is a bit of a weird mind explosion when you're typing code and suddenly objects are appearing around you that you've coded, but it's also really, really fun. So this is really good because it's great for suddenly going in. I think on the main page of Primrose, you can literally click to go onto a meeting space where you can chat with anybody else who's there. Chances are nobody else is there right now because it's not really a time for Americans to be up and they're American. But you never know. How many people have heard of React VR? Cool, that's surprising. It's not officially released, so that is fair that you guys don't know about it. How many people work with React? Excellent. The React team are building I guess it's like another version or an add-on to React where you can build VR experiences using your React skills. You can do that with A-frame as well, so there is also an A-frame component that'll let you structure it all with React. So you can do React and A-frame, but this will be more native to React, where you can start building VR. This comes with with Facebook creating their own browser. That is going to work very well with React VR. Cool. So A-frame, that's what I'm most likely going to get most people who come to the workshop to do, because it is fun. It's basically a web framework for building virtual reality experiences. Code looks like that. This is, I think, the only slide I'm ever going to show code. But it is really simple. You have like tags which are like sphere, box, cylinder. Say where they're positioned, give them radius, a color, and then that's literally kind of all you need to do, and you'll have a really simple sort of experience, which in the end looks like that. And it doesn't have to be a VR app. You can make it into a visualization that people on a desktop can just look at and view and kind of walk around in. You've got WASD controls, so I can go and explore around them. So you could make a game that's 3D as well. It doesn't even need to be VR. It can just be a 3D thing. That works. You avoid delving into all of those things just to work out a quick prototype. You don't have to understand how a lot of it works. You can just build stuff for today and then look into web VR and all the complexities of how it's all doing things later. It also works on non-web VR-enabled browsers. So like the joys of the internet, it's not kind of finalized yet. We've got a WebVR 1.0 spec, but it's not really in browsers completely yet. A-frame has a bunch of polyfills to make it work in most other things, and in most mobile devices, smartphones, it'll work straight away. So it is good for that. A-frame also keeps up with all the changes. So like every new spec, it's going to change pretty rapidly as they start to expand and try and encompass all of the VR headsets. So A-frame is a good way of kind of keeping it, knowing that what you've built won't have to change too much when they change things. It's also free to build in open source, so if something's broken, you can help fix it. It's also much better than, say, if you build in Unity and something's broken in Unity, there's absolutely nothing you can do about it. It works with all of those things. How many people have tried the Daydream headset so far? That's cool, not many. I only tried it a few days ago. It should work with that too. I haven't gotten to try it personally yet. Yeah, you don't have to know JavaScript. So how? Download A-frame, and you have everything, basically, almost, not really. If you want to see it in VR, then you can get a bunch of browsers for your computer, or you can run it on Chrome on mobile. There are a bunch of tools. I'm going to give out a link for this later for everybody who wants to join the workshop or who wants to get there later. There's an inspector for it, so you can literally not even understand coding and just go into the inspector, move objects around, and see what happens. There's a 3JS inspector for anybody who's also worked with 3JS. It works, but it's kind of overkill for this. There's a registry of components, so there's a lot of stuff which you don't have to even understand how they built. You can just import in things that people have already put together. And one of the exciting ones of that for the Vive is, while you've got the Vive here today, they've got components for teleporting and using the controllers in the Vive, so you can create a whole world which you can then click and teleport around in and stuff and explore from all different angles. So there's stuff like that where you don't have to build it yourself. It already exists. Just throw it into your project and explore. There's an awesome A-frame page which has a bunch of projects that people have already built if you're looking for inspiration. There's the React thing if you use React. I think there's also an AngularJS one. I haven't tried it. There's a way to export Unity scenes into A-frame. So if you're somebody who's worked with Unity before, you can just grab your entire Unity scene, export it out to A-frame, and then continue on with life. And you are free. If anybody, and this isn't just for VR, if anybody wants to prototype something which is for both front-end and back-end, hyperdev.com is really, really cool. So if you want to quickly throw up a prototype, but you don't have to set up a back-end environment, throw up servers, try and get onto Heroku and set all that up, this is really good. CodePen is also OK at some of it, but if you start doing a lot of back-end stuff, it won't quite work. There's also something called blockbuilder.org, which I've been recommended a bunch of times by WebVR people, but I don't like it, so yeah. OK, what can I actually do? I'm not going to show actual links because we're definitely running out of time, but you can do tilt brush-like 3D painting. So the guys at Mozilla have built one where you can walk around a 3D space, paint in the air in the browser, and create whole 3D artworks. Because it's open source, if you've got an idea where you could leap off that and create something with it, you can literally take their 3D painting app and make your own. They've got audio visualizations, things like co-presence in VR. Let's see whether, if I go out of here, there we go. That's a painter. I won't play that. Oh, I don't have it there. That's okay. Oh, I know why, because it requires to be loaded first time. What this is really similar to the Spotify example you guys saw earlier. You can speak at it and get it to play a song. So I'm going to say an awkward one so that nobody judges my actual music taste. Play Justin Bieber. No, a lot of the time it doesn't work in presentations, I think because the HDMI cable's connected. But what it does is it'll start playing an audio visualization around the space. So you'll start seeing the sound waves and stuff in rectangular bars, and he starts kind of mouthing words or something. It is cool. Co-presence is a really cool idea. So I'm not going to play the entire video, but I'll try and skip to him if it loads. Basically, he can put on a Google Cardboard headset, give somebody else a Google Cardboard headset. They can chat from around the world and look like weird square things, which you can see kind of up there. So using the various JavaScript capabilities and WebRTC, if he looks down or up, it changes his size, and it also changes the pitch of his voice, which you don't get here, and I'm not going to kind of speak it aloud for you and stuff, but he can then speak to somebody around the world using this as well, without having to do an install or anything, and just kind of, it works. It's not built in A-Frame. This one is just built, I think, straight from scratch using WebVR, but you could build stuff using A-Frame as well that does the same thing. There's the A-Frame web page. Okay. Physics work as well, so if you want to do physicsy stuff and throw a ball at like a tower of things and see what happens, that's all possible. There's a WordPress template. I don't know how you could use that, but if you wanted to bring your WordPress into 3D for some unknown reason, maybe you've got a better imagination than I do, do that. If you like Tumblr, they've made Tumblr visualizations where it turns any Tumblr you want into an art gallery that you can explore. That gets weird, depending on which Tumblr you choose. There's a racing game, which is okay. It was made by, I think, the team at Samsung. I'm just not sure whether it will make some people feel sick if you're kind of moving and swirling around, but it seemed quite cool. You can make things like procedurally generated forests, which you could explore, or using JavaScript. So there are like options galore. Try linking other things. So if anybody here has a Pebble Watch or a Leap Motion or anything else that connects via JavaScript, if you've got Arduinos, all that stuff you could link into your VR thing and make something really cool. Basically, yeah, power is yours. I run devdiner.com. So even if you don't come to the workshop today, if you are wondering how to do all this stuff, I'm available to talk about all of the aforementioned things there. So if you want to get into VR or AR or wearables or smartwatches or the Internet of Things and Arduinos and Raspberry Pis, or artificial intelligence or robotics, they're all things that you can do with JavaScript. So come chat to me. I won't be offended if you have another workshop you really want to see instead of the WebVR one, but I'm still happy to share a bit of advice and guidance and tell you where to go and what links to use and stuff like that if you want to get started later on. I've got a newsletter and a Twitter if you hate email. I understand, where every week and throughout the week, if it's the Twitter, I send out links to what's happening in emerging tech. So if you're getting really overwhelmed by all these VR headsets I'm talking about and all these things that keep changing and React VR and when did that happen, I've got a newsletter which summarizes it all in single sentences. If this happened, go here to read more. This happened, this happened, this happened. And it makes a lot of people's lives a lot easier so they can focus on doing their work. If you're interested in coming and prepping for the workshop, that is the URL where I've got all of the links that I just showed right now. I will also give the URL again later if you come to the workshop and you didn't write that down. But yeah, come say hi, join the workshop. If you're intimidated by VR but you want to try the Vive, I may still let you just try the Vive and play around for a little bit. And yeah, come join us. It'll be fun. Thanks, guys.
Hello. We on? Yes. Cool. So we're running behind schedule already, but that is fine. Now we're going to split up. So talks will be happening here, and workshops down the other end. So on the left-hand side, we'll have Tommy with Cordova. In the middle, Charlie with WebGL. In the far right corner, we'll have PatCat with WebVR. And in front of him, also on that side, we'll have Ree with D3. We'll have volunteers giving out stickers, so if you want to help, or you want to just be, available to help, you can put on stickers of what you want to help with. And yeah, so before we do that though, so right now we're going to have like a 5-minute break to let people get to where they want to be before the talks start here. But just before I do that, I'm going to introduce the MCs for the first round of talks. So first up, we've got Mark Dalgleish, the original founder of Decompress from last year and the year before. Mark Dalgleish, and also Cade, who will be here later, I think. All right, there you go. Everyone, welcome Mark.
All right, thanks everyone. So yeah, we are running a bit behind schedule, but we're going to push on, and it's time for the talks to start. But before I introduce our first speaker, I really have to say, many of you may know the fact that I actually was the main organizer for Decompress the last couple of years. This year I took a bit of a break, much needed break. And I have to say, like, they've really, just like with JSConf and CSSConf, they've really stepped up the game, I think, the organizers. So first, I'd really like to have a round of applause for this year's organizers for putting on a great show. Yeah, what I really love about Decompress is, you know, with the JSConf and CSSConf, even though we have local speakers there as well, this is really our chance to show what the local Melbourne community is like and people from around Australia. And it's more about the community side of things, which can sometimes get lost in the, you know, the hustle and bustle of a big conference. So really love this event. And on the note of important local people, our first speaker is Rick Jenner, who is a real asset to the Melbourne community. I first met him at Be Responsive meetup here in Melbourne. But he's also been involved in BuzzConf, which is a big technology festival that just ran last weekend. Unfortunately, I missed it, but it looked like I missed something really great, so I should check it out next time. He's here to talk about something that's really important. We've talked about it the last couple of decompresses, and I'm glad it continues to be relevant, and that's the topic of accessibility in single-page apps. So please join me in welcoming to the stage Rick Jenner.
Okay. Can everyone hear me okay? Brilliant. It's great to be here kicking off the first proper presentation of this morning. I'm surprised there's so many of you. I would be down the back. This sounds like some awesome workshops. But I promise to try and keep you entertained. As Mark said, I'm very heavily involved in the Melbourne community. I love the development community here. I ran BuzzConf last weekend. It was heaps of fun. I'm also a co-organizer with the AngularJS Melbourne community with Alex Borokovich. So we're going to see a few Angular examples as I talk about accessibility in single-page applications. So I'm going to start off by setting a bit of context about accessibility. So this is a quote from Tim Berners-Lee. Timmy was the inventor of the internet. The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. Now, when the internet was conceived, it was responsive, it was accessible by its nature. And our thirst for ever more complex web applications has kind of broken this a little bit, and we need to remember and work a little bit harder to make sure that our applications and websites are accessible for everyone. And also the very nature of accessibility. Instead of focusing on the technical aspects of accessibility, it's important to recognize that usability is also an important aspect of accessibility. Now, this is really key as well, because this is the difference between meeting minimum accessibility requirements and actually building an application that is usable. Right? So this isn't just ticking the boxes and saying I've included an alt tag, therefore my image is accessible. This is knowing that that alt tag is descriptive and that someone can use the application or website you've built. So in the remaining 13.5 minutes, we're going to try and cover quite a lot. Now, a lot of these topics are relevant to more than just single-page applications, but there's some key things that I want to try and bring your attention to that where we sometimes break these more than others when we're writing our applications. So accessibility starts with a good design. This is my favorite design, not because it's good, because I think it really illustrates the point. This is a collection of various grids, a mishmash of shapes and colors, images, links, and text. For most people that would describe themselves as not having any disabilities, this is not very usable. This is the website equivalent of a bowl of Cheerios. It's a Jackson Pollock without any artistic merit. It's a real mess. It's difficult to understand. But now imagine that you have some form of cognitive disability. Imagine that you're trying to use this website with a screen reader or access the parts with a keyboard. This would be impossible for most people to use, but with a disability, it really is impossible. And although this is an extreme example, anything that is overcomplicated is also going to be difficult for a lot of users. A good test is turning off your monitor and trying to use the website or the web application you've built with a screen reader and a keyboard. If you can do that, you have a usable design. You have something that is probably going to be usable for most people, and therefore it's also likely to be much closer to being accessible. When you start thinking about that, you simplify, you just show the relevant information, and that's really important for a good design. Document structure is another aspect that covers the whole of the web, not just single-page applications. But when we deal with dynamic content, it's really easy to break a document structure. We're building little modules, directives, snippets, whatever they are, and we're throwing them on a page together. They don't have any awareness of where they are, and we can put them in any order and break what is essentially a good document structure. If we start with a good document structure, it means that when we do start considering accessibility, screen reader, keyboard access, we can go a lot further than just navigating that website using the tab and arrow keys. We have the ability to navigate to navigation, to headers, to read out the number of items in a list. This is all really, really helpful for someone that can't see the structure of a page. So this is a random website from my history. It's a BuzzConf website. And it has a pretty typical structure. It's got a logo, a navigation along the top. It's got a heading, some content, a subheading. If we look at the actual markup, we can see that it's semantically described. It's easy to read. We've got a head block with a document title. Within the body, we have a header. It has a navigation tag. It's got list items inside it. We have a main block, and it has a single H1 attribute, and then below that it has other headings and other content. Now, this is really key. So in a single-page application, we don't cause a full page refresh when we change to another part of the page. We just change the view. So let's do that. We'll change the view, and we'll go to another part of this website. So this isn't a refresh. This is just changing the view. It's the same menu. It's just different headings. It's got a different document title, and you probably can't see that, but in the tab on the top on the browser, it's got a different document title. So a screen reader should announce that change, should announce the change in the title as if we're going to a new page. And the way we can do that is pretty simple. Now, this is an Angular example using ng-route. There are lots of different examples. We have the route defined, we have the title defined, and the bit down the bottom, when the route has finished loading, we're just setting that title. And that's really important. That's really important. It gives context to people using the page. And here's a similar example in React. This is a very, very small amount of code, but it's very, very critical to help preserve that structure. Now, focus is also important. Again, across the whole of the web, but it's very easy to break focus when you have complex applications. We're changing the view, so that part of the page that might have had focus suddenly isn't there. And because we're not causing a refresh, a screen reader isn't going to start reading the content automatically. We might also lose focus when we delete an item from a form we have, or when we close a modal. So we need to start to be explicit about managing our focus. We're back to this random example. We've changed the view again, and we want people to know that the content on the page has changed. So we might set the focus to the new heading of this page. And we can do that very, very simply again. I'm going to read from the bottom here. We start down the bottom. Do I have a laser? Right, so we're starting looking at here. We are finding our H1 tag, and because our document structure is correct and valid, we only have one H1 tag. We find that. If it's there, we set an attribute of tab index to -1, which means programmatically we can set focus, but you couldn't get there by hitting the keys. And we use JavaScript to set the focus to that H1. Now, up the top, we also do a little check to make sure that we're only doing this if the application has history. That is to say, not when you first come to the page, because we'll have a full page refresh. When you first come to the application, it will automatically start reading from the top down. But when we change the view, we just want to jump to that H1 and start going from there. Keyboard accessibility. We can't really talk about accessibility without talking about the keyboard. This is one of the most fundamental and arguably one of the easiest areas to address. But we have to be really careful with single-page applications because we can really screw this up. So I've got 4 code examples up there. We've got some React where we have a on-click attribute on a div. We've got some Ember and some Backbone where we're attaching submit or click actions to headings. And the div down the bottom right is Angular. We've given it a class of button, and we're attaching a click attribute to it. So what's wrong with all of these examples? Who's got an idea? I didn't hear that, but I'm going to say yes. We are binding interaction events to something that should not be clickable. Links and buttons are clickable, divs and headings and other random elements are not. And this is really, really important because a screen reader is not going to tell you can click these things. This is fundamental and so important, it really makes me sick when we get this wrong. So I'm going to digress for a little moment and talk about links and buttons, because I've said that these are the clickable parts, but when do you use a link and when do you use a button? They have different properties. A link, you click with the Enter key. It has focus, hover, active, link, and visited pseudo classes. And you can open it in the new window, commonly by using a right click. So this can be used for changing a URL or causing a browser redraw. A button, you click with the space key. It has different pseudo classes. It has a disabled property. It will natively submit a form. So this is perfect for submitting a form, opening a modal, executing a piece of script. So when you're deciding whether to use links or buttons, consider this. If a screen reader user tabbed onto an interactive element, would its role tell them what to expect? They need to know this, because if it says this is a link, they will be hitting one key. If it's a button, they would be hitting another key. If you're suppressing features like the href, if you don't want them to open a page in a new browser window, consider using a button instead of a link. These tips came from an excellent article by Mary Sutton. I'll put up all of the links later on. There's lots more tips there. So here's a couple of examples of a link and a button. In the first example, we've got a link. We know it's a link. It's got an href. It's going to go somewhere. It also has a click attribute. That's fine. You can still execute scripts with a link. And below that, we have a button. It doesn't go anywhere. It just performs a script. In this case, it's a toggle. We've also got some hidden text in here. And it will show one or other piece of text depending on what's happening. So it will say hide details for this thing or show details for this thing depending on what's available on the screen. Now here we could use ARIA expanded for those of you that know a little bit about ARIA, but I like using visually hidden text in this example because the next slide is about visually hidden text. This is really important as well. We can bring extra information to people that can't see what's going on to help give them context. And a little bit of CSS like this will allow us to do it. So on this page, we've got 3 different accommodation options for, let's say, a technology festival, BuzzConf or something. You may want to buy one of these accommodation options. And for those that are able to see, the add buttons are underneath a heading, so we can see you could add a dorm room or add a campsite. But if you were to just go between these clickable elements by pressing tab, a screen reader is going to just read out add, add, add. It's no help at all. So we need to add something in there. And a bit of hidden text like this, where we're bringing in the accommodation title into the button, will allow people to have a bit of context. So now those buttons will be heard to say add a dorm room. ARIA stands for the Accessible Rich Internet Applications. Now this is a really, really useful collection of properties that screen readers can use to enrich the experience. And they're very important in single-page applications. ARIA Live is a property that is often abused, but very powerful when used correctly. And it will announce that a part of the page has changed. So in our top example, we've got a button. And the value of that button will either be the word search or searching, depending on whether it's clicked. And we want that change to be read out when you click that button. When I submit the button that says search, I want the screen reader to announce searching. Just a little tweak to give someone with assistive technologies a little bit of context. And we're giving it the attribute of polite, which means that a screen reader will wait until it's finished reading the current block before it announces this next bit. In the bottom, we've got, let's say, some pagination. Again, the ARIA Live of polite, and it will say showing n of x. But we've also added a property, ARIA atomic equals true, and that means it will read out the full content of this element. So if we are saying showing 1 of 3, and we go to the next page, the number 1 will change to a number 2, but we don't just want it to read out 2. That's no help. We want it to read out the whole line. So by saying this is an atomic element, it will read out showing 1 of 2, showing 2 of 2. There's lots of other ARIA attributes as well, and there's libraries that will add these in automatically for you. A couple of examples up there. So when something is dynamically hidden by your single-page application, it will add an attribute of ARIA hidden so your screen reader knows not to read it. For form validation, it will add ARIA invalid for elements that are invalid. All really, really useful stuff. Build tools is the final thing I'm going to talk about, and I've got a massive 1 minute and 10 seconds, so we're going to flip through this pretty quickly. There are a few tools out there that help our job. I'm going to go back because there's a stat here. Carl Groves, who wrote Tenon.io a fair while ago, 3 or 4 years ago, said that only 18% of the WCAG guidelines for accessibility can be tested automatically. And that number's probably still fairly accurate. We can't use build tools to do all of our job for us. Remember, this is about usability, not just about ticking boxes. But we can get it to help catch developer mistakes. And tools like Axe are great at doing that. There are protractor plugins for this. Phantom.js, if you use that, again, there's tools that you can use to plug in that will remind you of those things that you've missed. They will say that your image is missing an alt tag, or your HTML tag is missing a language attribute. They might tell you, check that this is descriptive and valid. So in conclusion, remember to start with a considered design. And code semantically, that will really help. Test early and continuously. Embrace ARIA, but try not to rely on it. Turn off your monitor and try to use your application. It's so easy to get an experience for what millions of people in Australia, and we are talking about millions who use assistive technology. If you just turn off your monitor, you'll understand what they're going through, and hopefully you'll be able to code better websites. Thank you very much. Slides will be online, and all the references as well, so I'll post them later.
All right. Thanks so much for that talk, Rick. That's I definitely have to really stress what he said about turning off your monitor. That was something I did myself over the last year or two, and it's that one thing. If you're going to do anything, it's do that. It completely changes how you view websites. Next up, we have Mike Reith-Muller, who's joining us from Canberra. And I first met him at CSSConf last year, where he gave a really great talk called A CSS Eulogy, which is on YouTube, so go have a look. It's a pretty funny talk. And he's here today to talk to us about advanced fluid typography. And I believe his laptop's ready to go. So, no, that's all right. So, just didn't want to leave him hanging. So, if you could join me in welcoming to the stage Mike Reith-Muller.
Thank you. Let's just see if we can get this up. All right, excellent. Sorry, folks, I'm just having a tiny bit of trouble here with the browser crashing. Let's relaunch. Okay, yeah, so sorry about that. There we go. All right, so yes, I'm Mike. I've just spent the last sort of 8 months traveling around Europe and hiking places, and these are some of the photos I've taken. I've put those on my title slides. It's nothing to do with my talk. It's purely self-indulgent. They wouldn't let me do a talk about travel, so enjoy those. The title of my talk is Advanced Fluid Typography and More. And hang on a sec, I haven't got my slides up because my notes. And I put little and more there because a lot of the techniques that I'm talking about, they relate to more than just typography, and more importantly, the broader concepts that I'm talking about can be used anywhere in web design as a way of thinking. And I want you to pay special attention to that theme and that way of thinking because it's something that I want to discuss with you. And that is that theme. I'm not going to make it difficult for you. I'm going to be talking about an alternative approach to responsive design. And I'm going to ask you to maybe think about putting media queries and breakpoints largely aside and thinking about other techniques, things like viewport units, calc expressions, and what they can do as a way of implementing some responsive design patterns. Now, although we all like to think that we live in this wonderful post-pixel utopia, the truth is we all very much think in pixels. In fact, it's a widely known secret that all the unit types we regularly use are just an abstraction of a base font size, and we usually know this to be 16 pixels. So we've never really given up complete control. It's not a difficult calculation to work out what the pixel size of something on the screen is going to be, and the chances are you do this, whether you do it knowingly or just intuitively have an idea of what the pixel size on the screen is, the chances are you are doing that. But of course, who doesn't love correcting someone on the internet? And this is literally the internet live at the moment. We're streaming this, right? So if you have a look around in the people next to you, if you see someone with a smug smile on their face, the chances are that they're thinking, well, actually, Mike, a percentage width is relative to the parent element, not the base font size. And okay, fair enough. Very, very clever, Melvin. You got me. But the truth is, when this happens, we try to control it with media queries, containers, grids, layout systems, and more to make sure that our responsive components play safe within our pixel boundaries. And of course, this panda is a metaphor for a responsive component, trying to break free of the systems and limitations we've put around him. And is that a stretch of a metaphor? It absolutely is, but I think that you'll agree it was worth it to get this guy on a slide. So the point that I'm not getting at is that whilst percentages might change, 20% is always 20%, right? Whether it's on a smartphone, I'm over here. Whether it's on a smartphone or a desktop, 20% is always 20%. So we've come to accept that this is how it is on the web. And I think that when we get to this way of thinking, we can become closed to new ways of thinking and fail to see better options. We just accept that that's how it is. And so those limitations may have shaped our thinking. I don't know if you've seen this before, but if you draw a circle on the ground, a cat has the tendency to want to come and sit inside it. And I think that as web designers and developers, we do this as well. We draw our own circles and we sit in them. And it's not that uncommon. In the early days of like computer animation, video games and film and things, a lot of what they did was borrowing from the mediums that came before them. So I've been told that like early television was a lot of people describing the set that they were standing on, because that's what they would have done on the radio. And you can do this on a broad level, or you can do this with specific technologies. And I think that we do tend to do some of this on the web as well. But what if these are perceived limitations? What if we could have something that, say, starts off at 20% on a small screen and fluidly transitions to 50% on a large screen like this? Well, the fact is we can do this. This example was recorded in a browser, and it's not 150 breakpoints. It's a real fluid transition. It's achieved with calc and viewport units. And I'm going to show you how you can do some things like this, as well as other techniques for achieving min and max font sizes, fluid modular scale headings, and a few other tricks. But first, let's take a look at existing responsive typography. And I think it's fair to say that existing responsive typography techniques are not ideal. Now, the problem that I have with examples like this is that they're clunky, they require multiple media queries, And they don't necessarily scale in relation to anything else on the page. So like our panda, they can trigger overflow, jump out of containers, and things like that. Why we've persisted with these methods for as long as we have, I'm not sure. Not when there's better options. So viewport units scale fluidly, but as you can see, they're not without their own limitations. They're really well supported as well. In fact, IE9 was an early mover on this, so you can get them all the way back to IE9. They're quite easy to understand as well. But yes, there are some limitations. When you get down to small screen sizes, you can barely read that, right? But again, these are perceived limitations. So we can get a minimum font size with calc, right? We just say 18 pixels plus 3 viewport widths. This means that at a viewport width of 0, the font size is going to be exactly 18 pixels, and from there it will scale at the same rate as 3 viewport widths. Now, more often than not, we might want a font size that stops scaling at a viewport width other than 0. And of course, we can do this with media queries. So here I've set a font size of 18 pixels, and then above 600 pixel media query, I've set the font size to 3 viewport widths. And if we do the calculations right, we can work out the exact point where 3 viewport widths equals 18 pixels, so that there's no jump between a fixed and a fluid value. And it works like this. It's the font size divided by the number of viewport units divided by 100. So 18 divided by 3 divided by 100 gives you 600. And that's where our media query was. And if you've been paying attention, you will have worked out that, hey, I can do that for maximum font size as well. So here's another example. 3 viewport widths, fluid, and then above a certain size, we've chosen 24 as a maximum. So we do 24 divided by 3 divided by 100, and that gives us our 800 pixels there. So when I'm doing this, I like to look at a reference like this to get an idea of how the different viewport units scale across different screen sizes. And those of you that have been listening intently will be going, well, there's still limitations, right? Essentially, we're confined to one column of this table. If I wanted a font size that started off at, say, 10 pixels at a 500 pixel viewport width, and then scaled to 24 pixels at an 800 pixel viewport width, I couldn't do that, not without a breakpoint. And as well as that, we were calculating where those media queries should be, right? Not choosing them. So every medium has these limitations, and sometimes it's hard to know when things are perceived limitations. It turns out that this one too is a perceived limitation. With viewport units and calc, you can have typography that scales between specific pixel values over a specific viewport range. It looks something like this. And I know that looks a little scary, but quite simply it's a function where viewport units are the variable. This takes a value within a range and applies that value to a new range. So if I had a range of 1 to 100 and a value of 50, and then I applied this to a new range between 1 and 200, my new value would be 100. Both of those are right in the middle of those respective ranges. The thing here is I'm doing it with viewport widths and font sizes. Now, functions can be simplified. That doesn't look so scary. And this is what it looks like. So as you can see, as you go down, the font scales. It gets to a minimum size and it stops scaling, and the same on the way up. So there's the font stop scaling. Now that's pretty handy, right? But what else can we do with that? So sometimes you might want to selectively turn this on and off. And what I typically do is I apply that calculation to the root EM, the HTML element or the root element, and then I just use REMs throughout my design. I don't want lots of those calculations all through my style sheets because maintainability is important too. So if I'm doing that and I want to turn it off, I can put a fixed font size on a container and then use EMs inside that container. I can, of course, do the reverse too. So this is what that looks like. So as you can see, I've got this little block off to the side here. It might be like a caption or some kind of aside to an article piece. It's not the best design thing. I'm sure you can do better than that. But I hope that that shows an example of what I'm getting at. And I don't think we see much of this kind of thing because if you're using breakpoints, it's not that easy to do that type of thing. So are a few of you feeling like this? Mike, this is confusing. I want to use fluid typography, but I don't want to have to remember stuff. And that's fair enough, right? So let's just forget all of that and use SAS, right? So cheating with Sass, and of course it's not cheating, this is how I do it as well. You can create a mix-in that will generate that equation for you as well as the media queries that you might need. And you just set a minimum font size, a maximum font size, a minimum screen size, and a maximum screen size, and you punch them into some kind of mix-in. I haven't shown the mix-in code there because it doesn't really matter. There's lots of them out there. If you Google for them, you'll find like less, Sass, stylus, post CSS, whatever you want. If you can't find any of them, feel free to hit me up on Twitter or find my blog. It's made by Mike. There's examples up there. So what else can we do with this? Fluid modular scales. How many people know what a modular scale is? Oh, about half, I would say. So I think it's best described visually. Each of the headings here is 1.2 times the size of the previous heading. That means that as they get larger, their variation in size also gets larger. And typically when I'm designing or setting typography, I like to find a scale that works well for mobile devices and a scale that works well for desktop. On desktop, I think it looks better to have more variation, and on mobile, I like to have a more uniform scale. So how do I do that? Well, calculating a modular scale is really easy, but this is a 15-minute talk, and we don't have time for that. So go to typescale.com, choose a size for small screen, and choose a size for large screens. Copy all of those values, and you can easily change those values to REMs, pixels, or whatever you want to do. And then copy them into the mix-in like this, where the value from one scale is your minimum value for one heading, and the maximum value is the other value that goes into the mix-in there, and you do that for each heading level or each element that you want on your modular scale. And the result looks something like this. So as you can see, it transitions to a more uniform scale, and then as you go up, it's more varied. And I don't know about you, but headings have always been the thing that I've had the most trouble with when setting typography. And this particular technique just solved so many things for me. I'm not saying it'll solve all problems, but it's really nice to just put in and see it sort of work and be right on every screen size. But of course, it's not just typography that you can do this with, right? So who hasn't struggled for the perfect implementation of a responsive banana? So this isn't just font sizes again. This is scaling the width and height attributes of an SVG. They're both length values, right? So I just wanted to show that you can do that. Here's another example where I've implemented a fluid vertical rhythm. So you don't have to throw out everything you know about design, baseline grids, vertical rhythm. Those things will work. I've written a little bit about this. Some other people have written about this as well. If you search for that, you'll find those implementations. You just need to think a little bit differently to maybe what you're used to, and maybe give up a smidgen of that control over pixels. This is another example. Again, it's not the best design, but there's a lot going on here that's interesting. The images are transitioning between a 1:1 ratio and a 16:9 ratio, so square and rectangle. The spacing around the boxes is changing relative to the available space in the viewport, as well as inside those boxes, so sort of they're spreading apart as well as sort of spacing themselves out. And the result is like a tight Instagram-y type layout on mobile, and a more airy scrapbooky type thing on desktop. And again, it's not perhaps the best design, but I can't think of any other way you could do this currently with the sort of layout techniques that we have. So I find that interesting, and I'm wondering what other people can do with it as well. So we've looked at some things that we can do today with this, but what about the future of fluid typography? Has anyone seen this before? No. So this is an example by Eric van Blocklen of a new font format, variable fonts. And what this will allow is for font designers to specify limits of how bold, how italic, as well as other custom axes that we might not have even thought of. So as designers, developers, we'll be able to choose any value without downloading multiple font files as you would have to at the moment. So as well as saving multiple font files from having to be downloaded, we could be able to interpolate these values, right? There's an excellent article on A List Apart by Andrew Johnson that talks about live font interpolation on the web. And in this, he touches on the problem that I've been describing today of he calls it bending points in design rather than breakpoints. And I think that either side of a breakpoint, typically, the design is sort of already burdened by the thing that was putting pressure on it, saying that we needed to have a breakpoint there. So often I find that it's not ideal either side of the breakpoint. It's kind of a compromise point, really, isn't it? And I also think that it's important to remember that media queries have been around longer than responsive design. They're kind of a response both to a user need as well as a response to the technology that was available. If we were to do this today and look at responsive design, free of those past perceptions and perceived limitations, what would we develop as the right tool for implementing responsive websites? And that's why I'm proposing that we need a native interpolation function in CSS. Now, if you've used interpolation in animation, you'll know that we have animation timing functions, cubic beziers, and things like this that allow us to sort of ease values in. All of the techniques that I've been talking about today relate to length values in CSS, pixels, REMs, all of that kind of thing. But there are also other values. And what I'm worried about with the variable fonts is that a lot of those values aren't pixel values or length values. They're unitless values, and these techniques won't work with that. So I think it's really important that we start talking about getting something like this. And that's why I've proposed an issue on the W3C's GitHub page, and I'd like to encourage you all to go and have a look at that, or even just talk to me about it if you have any ideas, and contribute to that discussion, because I feel like at the moment, if we don't sort of get this right, we'll get these new tools, but we'll still be constrained by past limitations, past perceptions, and those kind of things. So I want to encourage you all to do that. And in general, on the theme of what I've been talking about today, I want to encourage you all to get out there, go forth and explore strange new worlds. Today we've looked at and explored the sort of limitations of fluid typography, but this is just one small area of the web, right? And if you're free of your past sort of perceptions and your perceived limitations, then you can go and find sort of new territory anywhere on the web. I don't think there's been a better time for doing this than now. And most importantly, with new typography and layout features coming soon, I think there's an obligation to go and do this and to adjust your ways of thinking so that you're ready to take advantage of the opportunities that are coming today. And that's what I want to leave you with. Thank you very much. There's a URL there with a few examples if you wanted to try implementing any of this.
All right, thanks for that, Mike. So after this next talk, we do have another talk, but this is my last MC slot for the day. But I have to say that during the break, during the lunch break, there's going to be the Meet the Meetup session, which I'm sure you're aware of. For those of you who don't know, I run Melb.js here in Melbourne, and I've been doing so for a number of years. So I guess particularly if you're out of town and you're curious about the local JavaScript scene, please come and chat with me. Or if you're local and you want to give a talk at some point, that's even better. So come find me, and I'd love to chat to you about that kind of stuff. So up next, we have Jessica Claire Edwards, who's joining us from Sydney. And she's a self-described creative developer, which is my favorite type of developer. It's certainly better than an uncreative developer. There's so many new APIs, particularly on mobile, coming to the browser. And so on that note, Jessica's here today to talk to us about enhancing mobile experiences with device APIs. So please welcome Jessica.
So let's kick off. Mobile sucks. That's it. There's something deeply inadequate about mobile. Scott Jensen, who loves mobile, he's on the Google team, and he noted in January that mobile still has so much to learn from desktop user experience. For mobile, it's a gimmick, basically. You don't do any real work there. It's it's just not feasible. I mean, it's not about CSS, definitely not. I mean, by the way, this is the Bootstrap CSS. And if you were wondering what the next media query had, it's, again, padding right, 15 pixels, padding left, 15 pixels. Yeah, and I mean, we solved it. You only need that one layout, and then that's it. That's Facebook, that's LinkedIn, that's Twitter. We're good for layout, we're done, but it's still not, there's still something missing. It's just not usable. I can't give a talk with my phone, not yet. And it's not just me thinking this, it's 35% of our time is spent in social applications, 16% on entertainment, and that's excluding gaming. Whereas in terms of productivity, if you're searching, if you're researching, this is roughly about 10%. And it's not just about screen real estate, it's more than that. Tablet has similar numbers. If anything, tablet is more prone to these. There's about 20% in gaming. But this is not about CSS, it's not about layout. You came here for device APIs. Yeah, cool. To get started, if anyone, woke up today, I guess, and there was the Guardian used the vibration API for the previous election, and it was just like a notification like, hey, something's bad happened, we lost another state. And it's just that little thing. It's only supported in about 55% of browsers in Australia, the vibration API, and if you consider that it's mobile, you're probably looking at maybe like 30% support. Why bother? I mean, the vibration API has been there for a while, but I never see it. The only time I do see it is when an ad has hijacked my Android phone and starts vibrating uncontrollably. Before that was the first time I ever saw it out in the wild, and it served a useful use case. And I want the mobile web to be useful. Say we have a form, right? And we click submit, actually, I needed to do something else. You get that instant feedback. We need to move beyond just these gimmicks or like just delegating the real work to the desktop. For example, there's a geolocation API. This has been out for a while. The specs, it's older than my development career, to be honest. But really, what we want to do is minimize typing. Because it's not about being able to type. It's about getting the address. No one said that we had to type the address, right? We need to look beyond just this, hey, this is desktop, how do I make it smaller? And why is that? I mean, this isn't a QWERTY typewriter. I found out it's missing a Y, but I already really liked it already, so I sort of kept it in there. But QWERTY was invented about almost 250 years ago, and it's designed for 10 fingers, right? And that's what we have for a mobile where I'm using my thumb. Does it make sense? I don't know. I just like playing around with these APIs, but the issue is that I don't see them out in the wild, and that means I can't get to use them if no one else is. I'll say like device motion, right? This has also been out for a few years. Basically, it uses the 3 motion sensors, the accelerometer, the gyroscope, and the magnetometer, and basically it goes, hey, you moved. And the instant sort of, I guess, reaction is like, oh, cool, games. Like, we can, do something interesting. But this sort of thing. Say if we had a form and like an Etch-a-Sketch, we just shook it instead. You know, we just, instead of this, we can empty the form that way. And speaking about like the magnetometer, we have the Google Cardboard. For a button, it decided, hey, what's free and is easily accessible and basically, and it's supported in basically every single phone, magnets. You can use magnets as an input, and they've done this, and basically, it's ingenious. This is the early edition of the Google Cardboard, and you just flipped a switch, and this was your input. Because you can't press the screen. The screen is not available for you as an input anymore, so you have to get creative. And it was really ingenious. They've moved on, but and we have these, right? Pretty much every phone I can imagine for like our audience, it would have these rich sensors, right? So this doesn't look like much, but basically this is a ring that's got a magnet inside it, right? And the problem with, say, your classic smartwatch is that as soon as you interact with it, you can't see it anymore. This one, they've used their sensing for the magnet, and basically each direction that you put it is a different type of input. It's a different kind of gesture. And this is not obvious, but it's useful. And we can do this for the mobile web. We've just gotten access in the latest builds of Chrome to these really low-level sensors, such as accessing magnets. And the biggest thing is I want to move beyond what I heard this once, scrolly-telling. Scrolly-telling is every single website that we have. When you see a great experience on desktop, my first instinct is to go to mobile, and it's pathetic, honestly. It just doesn't give me that same like visceral feel. So it's not even about being useful anymore. It's just being an experience. It's not something to pass the time. And we can use something like, say, the ambient light sensor. So this is moving beyond like explicit forms of input, such as your magnets, such as touch, such as even sound. This is implicit. Maybe we can provide a different story, a different experience based on whether they're inside or outside. Maybe it's actually useful. Maybe if it's dark at night, you don't want to send the same really bright thing. It's just, I don't know, I've been blinded so many times at night, so I can imagine there's a common use case. And we can solve that. And see, then there's this stuff. There's like these kind of bad, like privacy implications. And I say really bad, but I see this, right? Pin skimming, exploiting the ambient light sensor in mobile devices. So basically, it uses the light sensor to determine what you're doing with your fingers, basically. And there's a lot of bad cases out there of this, but I see this, and I'm really inspired. I think this is, imagine if you came up with that. Like, damn, you deserve my pin. Come on, like, it's just about, we have these sensors, and we've had them for a long time. Geolocation, the device light has been available in Firefox for a long time. You can play around with it in Google Chrome as well if you just go to enable experimental web features, where all the fun stuff is anyway. And you can play around with it, but I guess the issue here is you can't polyfill hardware, right? You can't guarantee the same experience across all of your devices. But that's okay. That's absolutely fine, and that's what we should be encouraging. We pretended that we knew the screen size. We've used screen size as a proxy for some of these features. Like, well, if it's a small viewport, they probably have, they're using a touch screen. But that might not be the case at all. But what we're doing is we're trying to guarantee these different experiences at all the different times of day. Why not give them a magnet? And if they have a magnet, then they can do something a bit different. They can navigate a bit differently. This isn't how you do APIs. Like, there's a bunch of interesting work being done at the moment, really in the low-level sensors, thanks to stuff like the virtual reality specifications. And so there's byproducts of that for just the regular people that just want low-level sensors. But the issue is, yeah, we've had these for a long time, and no one's using them. And I just want to spark ideas. I want you to see this and be like, oh, wow, maybe I could not pin skim, but I could do something else. And it's just reconsidering. It's, what do you need to do? What does your client want? What does your user need? Not what have we done before. I want to be able to give this talk via a phone without my laptop. I want to be able to do real work. I want real enjoyable experiences on mobile. And I think device APIs is one of the biggest things that, as an industry, we're just not even considering at the moment. Thank you.
Thank you very much for that. Device APIs are pretty great, actually. Next up, we have Laura doing a talk called Dude, Where's My Tricorder, which sounds interesting as hell. Just to remind you all, lunch is coming up soon. We are running a little bit late, so at this point, lunch is going to happen at 1 o'clock. So we haven't forgotten about food. It's all coming, but we've still got 2 more talks. And then we'll be feasting. How you going?
Can't see where my screen is.
There we go. The screen's back.
There we go. There's my slides. Yeah, good. Let's make that big.
Fantastic.
Cool.
Take it away.
Thank you. Thanks, Cade. Hey guys, I'm Laura. I'm a designer and front-end developer. I'm currently working at a startup called Clover, which is fintech. Previously, I spent 2 years in a startup that was in the medical space, and that's sort of where this talk comes from. So basically, I'm here to ask you guys, dude, where's my tricorder? And there's a little disclaimer that there's actually several tricorders out on the market right now, but they all suck and they're just gimmicks. So just quietly, yeah, I know there are actually things, but they're not the real thing. They're not the magic, ooh, look, you have tuberculosis and you need this. So yeah. So let's talk about tech as a whole. Right now, we're in this weird space where some verticals are going wildly fast, and others seem stuck in the past. Now, this lady's got a little radio pager. I hope you can see that. And essentially, radio paging is from the 50s. It's one way. It's non-encrypted. It's this terrible little character box UI interface. Is that my earrings? I'm going to take them out. God, that's awful. Sorry. Let's just do one, and then I'm totally badass. So yeah, hospitals, there's lots of other verticals like education, government. I'm sure you have many in your brains that are slow to adopt the pace of change that we're seeing in other spaces. So whose fault is this? Well, I'm here to say it's big and it's complex and it's any person's fault, but there is a ton of literature on the web. I'm going to share these slides after, so if you want to read any of these links, there is an enormous amount of introspective, nasal-gazing, like, technology blogs and articles that are like, oh, Silicon Valley, why you so suck? Why engineers make stupid product? Well, okay, yes, it's hard. So I'm going to say, I think it's not a get blame thing. It's no one person's fault. It's big systems. And to be fair, hard problems are hard, right? Like, if we are trying to tackle a big, complicated, convoluted system, it's very hard even to look at it and break it down to a small piece and go, well, this is the thing I can tackle. Also, it's a business model problem. So investors like a scope that's small and contained, and they like business models they understand, and that's retail traditionally, right? Like, that's things that they've seen succeed, like Uber and Airbnb. So what we have to do is not just disrupt an enterprise, but disrupt the business model. So let's think about how we can do that. So if this is a thing that's been on your mind, if you actually want to tackle this, I'll put it to you that technology will be probably like the smallest part of your job, and the bigger part will be fostering that culture of change, both from the business model and VC point of view and inside the enterprise. And it helps you if you know what you're up against. So here it is, my little thesis for 15 minutes, a survival guide for bringing technological disruption to the enterprise. I'm just going to leave that there for a moment, because this is my proudest moment. Picard being amazing. So I'm gonna show you this through the lens of hospitals, but I think, again, it's important. Why this is important is because the problems we're seeing in the world, like economic problems, the rise of capital, the decline of the middle class, the wildly broken political systems we're living inside, like our inability to tackle climate change, all that stuff. These are all problems that are bound up in big, convoluted spaghetti string systems, and it's our job to like think about how we might potentially tackle even a very, very small part of those problems. So here's a first challenge you might come up against in the enterprise space. It is the tender process. Now, if you've done these before, you're about to know what I'm going to say, which is that they're terrible. They're long. They're time and resource intensive for the vendors. They're often written to actually like pick an existing vendor and like cut everybody else out. So that means that if you weren't on the radar before they wrote the tender, it's terrible. They often have really onerous requirements, so if you're a small startup and you've only been in business for a short period of time, it's basically saying, yeah, we're not interested in you, so that's not great. If you've ever been through this experience, it might feel a bit like, oh, hey, I'm here to like feel out the vibe, have a first date, maybe like have a drink, chat, see if we like have things in common and we have problems we're gonna solve together. And then the tender is like, yeah, no, you're gonna be having my baby. So, and again, like, my favorite, this is just an excuse for stupid Star Trek riffs, so yeah, that's what's going on. So they do a lot of prescriptive describing of what you need to supply, and that's just the wrong way to think about things. They should be telling you what the problems are that they're trying to solve, and then let you, the actual like experts, think hard about what technology solutions might solve those problems. So a lot of trying to fix this space is telling people how and why tenders are inefficient and poorly designed. So there's a lot of things you can try and do to make tenders better before we can kick them out the door altogether. While you're still in the tendering process, you definitely want to network. You want to get in front of the clients before they even write it. There are ways to deal with the onerous requirements for small business. So for instance, partnering with a big company, like in the health space, there's someone like Telstra Health. There's lots of big companies that are basically like really quite happy to put their umbrella so that they can take the glory of being included in this small startup like innovation community. So it is worth thinking if that's a good solution for you. You can also try and figure out if they have a purchasing budget which doesn't have a threshold requirement, a tendering requirement, because if you can sneak in underneath that threshold, then you might be able to get your foot in the door, and then when they look for the next big project, you're like already on their radar. So, and also, we just need to tell them that these processes are terrible and why and what kinds of outcomes they'll be preventing themselves from achieving, which is the technology they couldn't even think about to tender for, right? The solution they didn't even know existed. The next problem / challenge / opportunity I want to talk about is the sales cycle. This little link here is basically a long and interesting read if you're interested in the hospital space. It basically talks about how hospital admins make technology purchasing decisions, what are the triggers to get them there, and it's just a lot of terrible things, basically, like patient deaths and stuff like that, which is a thing that they never want to say. They always say, ooh, adverse outcome, but what that means is someone died because something stupid happened. So that's very representative of what happens in enterprise, I think. Like, they're very reactive. They wait for something terrible to go wrong, and then they're like, ooh, maybe we don't have the solution. So in terms of the sales cycle, it can be 6 months, it can be 2 years. It's very long. This is very hard for startups to survive. So if you're going to try and tackle the space, be aware that it's going to be long, and you need to have capital to survive that period of time. So yeah, don't go into this like naively. It's really important that you think, what can I do to survive that time, that sales cycle length? There's often a lot of stakeholders who have to rubber stamp the process. Also, in enterprise, they seem to discover technology vendors at trade shows, which is it's kind of old school, but then we have our trade shows as well, which is like CES and like the cool big ones in the States. So I don't know. I'm sort of half-half whether that's a good thing or a bad thing versus just finding internet vendors like on the internet. But that said, it's good to know that that's where those relationships traditionally form so that you can be in front of their faces. So how can we reimagine the sales cycle? Well, I put it to you that there is a ton of customer acquisition models in retail that we can steal for enterprise. So we have to work out how we can give them potential like deals or pricing points that are so appealing they can't refuse. So for an example, you might say, hey, I'm going to wire up my product, fully integrate it into your systems, and you can play with it for 3 months for free. Or maybe it's a year. Like sometimes they need a long time to make a decision. Another way is to tie it into a metric. To say, like, hey, you have wildly inefficient X, and we're going to see a Y% increase in that metric by using our tool. And if you don't see that improvement, you don't have to pay for it. So like, there are ways of getting around these sales cycles, and that's being so compelling that they can't say no to you. This is a fun aspect of working in enterprise, where the person who's using your tool is not the person paying for it. And in fact, the person paying for it may never actually use it or see it in production. Now that's very frustrating, because what can happen is all the standard customer satisfaction and success metrics that we love to use in retail space don't get applied in their thinking when they're making purchasing decisions. So it basically means that whether or not users like the tool, want to use it, and find it easy to use, don't seem to be at the forefronts of their minds when they're making that technology purchase decision. So, all right, that's pretty frustrating. And it also means that the people using your tool might have a little bit of latent frustration and anger because they're used to these top-down decisions being like, saying, hey, here's this new annoying tool you have to use. And you're like, oh, what do I have to learn now? So imagine like if your app store wasn't you going in and actually installing apps. It was just like, hey, today you have to try all this. By the way, that's your job. So thanks, Andy. So yeah, like for sure, it can be frustrating for people if they're just constantly being handed top-down decision-making. So I think the way that we solve this is to make user success metrics part of the deliverable again. So I think there's a bit of arrogance and there's a short-sightedness on the point of view of those decision makers when they don't think about how much the users want to use the tool, or whether it's got good UX, or whether it's going to be like an improvement in efficiency. A big way to have a think about this is enterprise traditionally has this phase called UAT, which is user acceptance testing, followed by a user training process. And these can be like literally millions of dollars and months long in like the overall project. Now, if your tool is terrible, everyone's going to be resistant, and this is going to take a lot of time and a lot of like bullying essentially to get people to adopt your tool. If it's really lovely, seamless, intuitive, and the adoption is really fast, you're just going to have all these people on the ground spreading it out. And in fact, theoretically, you shouldn't have to pay for that phase at all. It should just work because people want to use it. Or you get a couple of champions to explain whatever more deep or like powerful feature sets are there, and the basic stuff is already there. You can just pick it up and go. This is a phrase coined by my wonderful partner, Andy. And this is the airport where you have like the premium screening line, and then there's the general screening line. And essentially, this is this weird thing where people go through security, only if you pay a little bit more money, you don't have to take your shoes off. And like, it's like, how can that possibly be preventing a risk or saving people's lives or preventing a danger if you can just pay more money and then not have to do it? So this is like this weird appearance of safety that has nothing to actually do with risk management. And this happens so much in enterprise. Oh, stupid earrings. Take that one off too. All right, so the thing to do here is call it like you see it. So when you see risk management processes that are not working, you just have to shout out. And we do this really well in lean methodologies. We think about what's the best way to get better, and then talk about it, iterate, have a play. We're happy to drop tools really frequently. A good example of how this works in hospitals is there's this method of risk management called the Swiss cheese process, which is like each layer of risk management is like a layer of Swiss cheese, and it's got little holes in them, and like on its own, it's not a useful risk management tool because there's lots of holes, but they have this theory that if you put enough layers up, then you've filled in all the holes, and you're not going to get anything falling through the gaps. And that kind of makes sense, except it assumes that time, energy is infinite resources, that people are like completely forever will have time and energy to like perform those processes. And obviously it's not true. And essentially you end up with a stupid Swiss cheese sandwich that's literally too big to take a bite of. So I found this little quote from this lady in fashion, and it's really spoke to me because I feel like in enterprise, people are very good at sitting in a room and being like, oh, sure, yeah, that sounds reasonable. And in their heads, they're going, gosh, that's just ridiculous. Like, you know, if you've seen the like 7 perpendicular red lines video, you'll know what I'm talking about. It's like people just nodding along and smiling when in fact they're thinking, this is just ridiculous. So I think it's our job in this sector to call out when we see things that are really outrageous or inefficient or really just bad thinking and bad logic. The last problem I want to talk about is when UI complexity is perceived as being powerful or valuable. So this is a bit of a cognitive bias that can happen based on thinking that more things is better, essentially, that like the more you can shoehorn into your interface, the better you are. But when you look at things like hospital EHRs, it's very easy to go, well, how do we even start, right? Like, what's the first thing I do on this screen? And it's just such a mash. It's actually very reminiscent of Rick's design that he showed us earlier. And it's such poor usability design. It's such poor like decision making, because what they've done is gone, hey, everything you could possibly need ever is going to go on the interface here. And really what good UX is saying, well, we're going to give you some opinionated defaults about some basic features or some common functionalities we want you to perform, and then we're going to hide away all that complexity and bring it back if and when it's relevant to you. So bring it back in a contextual manner. And that is really the work of a UX designer. Like, they do all that work of thinking hard about what all the pieces are, and then work out when it might be appropriate to show that extra feature or that extra piece of information to the person. So again, how do we tackle this? Get your UX and product people front and center. Let them rabbit on about it in front of your clients during the sales cycle. Like, actually let them talk about it, because it's important that we bring this thinking outside of retail and into other sectors. Ooh, I'm running over, so I'm going to keep going. So to conclude, I think we can have nice things in enterprise. We just have to fight for them. And I hope I've convinced you that it's important and necessary, and that obviously we want to go to Mars, but also we want to have hospitals that don't suck. So thank you very much. I hope you found this talk engaging. Are you ready for my terrible puns? Hope you found this talk engaging. Please go out there and make it so. And Mike, I'm sorry, but I did this before I saw your slide. Boldly go where no startup has gone before. Thank you for listening. All the slides are up there. There's tons of articles if you guys want to read them. Chat to me in person or on Twitters.
was really great. Thanks, Laura. I love how much Star Trek imagery there is around today. It's really quite great. Lots of boldly exploring new ideas, things like that. We've got one more talk before lunch. This talk is by Francesco Orsinigro, and it's about a topic that's quite dear to me, Elm as an antidote for front-end fatigue. Laptop switching is the best. Hey, a dongle, a non-Apple dongle.
Ooh, it works.
Take it away.
I'm super excited. Oh. So Elm as an antidote to front-end fatigue. First of all, some context. This. So front-end JavaScript is terrible, and there are several different opinions about this. Something that most people more or less agree is JavaScript fatigue is a problem. What is JavaScript fatigue? It's the idea that things are moving so fast that we are overwhelmed by all this new technology, and we can't digest them fast enough. I think this is a problem, but I think this is not exactly why it is a problem. This is a page from GitHub. It's a nice tutorial that explains how to make a fully scalable web application using as few technologies as possible. It uses 9. So this is 9 different things as a baseline. A full-fledged production application usually will have a lot more than those. So I think that JavaScript fatigue is not that there are 1 million different libraries out there. It's that of those 1 million, we don't have to pick 3. We have to pick 9. In fact, we can see that the tutorial itself focuses on wiring the tools together. It's not about learning those tools, okay? If we continue, this is the table of contents of the tutorial. It's 12 pages. It's not 12 pages that explain you what the tool does and the options that it has. It's 12 pages of configuration. It's 12 pages before you can actually start solving your problem, writing your specific stuff, okay? This is frustrating, okay? It's not a problem of having many technologies. It's a problem of having to use many of them to have something acceptable, scalable, maintainable, and having to wire them together. Because the more moving parts you have, the more it's difficult to make them work nicely together. And it's not something you do once and then you forget about it. Every time you have to change something, Webpack will need a new plugin that must be of the proper version, and then Karma will come in complaining that you added TypeScript. Okay, the interaction are many and problematic. Now, how did we get to this point? Okay, because JavaScript is the only thing that runs on all browsers. The reason we are using JavaScript, it's because it's what runs on all browsers. But this is actually true. Well, we don't really write the language that runs on all browsers. We write JSX, we write annotated JavaScript with TypeScript or Flow, we write ES6, we write ES7, we write CoffeeScript, we write PureScript. None of those things natively runs in a browser. Why do we use this? We use this to try to patch up the flow, the problems that we have when using JavaScript. We are building workarounds on top of each other. It's a huge monster ball of workarounds. So what if we took a step back and reconsidered modern web development? Okay, how would this look like? We're compiling anyway, so we don't really have any reason to stick with JavaScript. And here comes Elm. Does anyone here know what Elm is? Anyone heard? Okay, so Elm is a purely functional programming language. It is strictly typed, which in turn allows it to guarantee no runtime errors whatsoever. It has a time-traveling debugger, which is just as fancy as it sounds. It cures cancer, it solves global warming, and it's yet the latest overhyped tech. We spent 2 days listening to hype of of different techs. And when we are offered something new, we think, is it really worth it? Do I need to learn a different way of programming, different libraries, new stuff? If you ask me, no, it isn't. Like, this stuff alone, it's, well, cures cancer and solves global warming, totally worth it, but I lied to you. Elm can't really do that stuff. I'm sorry. But those are not the reasons I ended up sticking with Elm. I ended up going through the learning curve. So why did I? What was the selling point for me? Elm tackles the problem from the ground up. It reimagines what web development would look like if it was designed with the modern web in mind. Elm, unlike many new technologies, does not try to play nice with JavaScript. You can use JavaScript and Elm together, but the design decision with Elm is that you want to write as much Elm as possible and do away as much as you can with JavaScript. This obviously comes with a cost. We have to learn new stuff. We cannot use many of the libraries that we learn to love with JavaScript. So do we want to do this? I would like to convince you that it may be worth it. There are some very good things that happen once we decide to do away with as much JavaScript as we can. So this is a very nice thing. There is a simpler build. And I can't use, oh, right, it works. So the slide that I was showing you, they are written entirely in Elm. So I have a very small repo with all my slide making stuff there. And what you see here is the repo. So there is an Elm package.json, which is just meta stuff about the package and dependencies. There is an Elm stuff, which is just the downloaded libraries, because I didn't want to risk the internet connection here and the download in front of you, because the gods of demo are evil and ficklish. An images directory that contains just the 2 screenshots of the tutorial that I showed you before. An index.html, which is actually what we generate, and a main HTML, main.elm. All the source of the presentation is actually this main.elm, which I'm going to show you. Okay, so we have some imports. This piece of code is behavior, so it's the definition of the animation for the fragments and the slides. Then we have some, we should recognize this. This is CSS. I am expressing CSS in Elm. We had a talk before where they wanted to have interpolate added to the CSS spec. We don't need this. We don't need SAS. We don't need less. We have the full power of a programming language to express CSS. We can use variables. We can use functions. We can use modules. This is neat. Below, I actually have the content. It is expressed as Markdown because it's faster to write than HTML. But I could have HTML. In the same file, I have behavior, style, markup. I don't have to do this. I can splitting modules. I can use normal CSS with Sass or less or whatever, but it's a nice to have. And drum roll. This is how I turn the code that you just saw into something that the browser can understand. This is not a trivial thing. The library is as a virtual DOM, is fully reactive. It has a lot of bells and whistles, a lot of nested dependencies. And here it is. The output is directly HTML. Normally, this is what we would need to do to gain this. 5 different steps, 5 different tools, all right? And compare with this. Bam. You know how I felt the first time I tried this? This was the fatigue going away. There are other nice things that we can do if we accept that JavaScript is not our main language. The type checking becomes reliable. Now, we have type checking already. We have TypeScript, we have Flow, and it's not like Elm's type checker can find different kind of errors, okay? It's not conceptually different, but it has a huge advantage. It is enforced all over Elm. You cannot write Elm code that is not type checked. This sometimes is a pain in the ass because you don't want to think about it, but it means that the code becomes reliable. Even the libraries that you're using, they are fully type checked. They are not going to have runtime errors. I spent one day last week because our application, it is importing the same library nested by other libraries, same library 6 times. That was an error that happened only in Internet Explorer 11, and I had to spend one day because a runtime error in Internet Explorer 11. Over 6 split libraries that I didn't even know which one of the version was it. You know how I feel when I have to think, wait, I don't have to debug Internet Explorer anymore. This is, again, fatigue going away. This is less technologies to configure and to patch together. This is bringing that 9 to 3, 4. Yes, and it's much faster because it doesn't have to run on all code every time. Third thing, fewer and simpler tests. Now, the best test is the one that you don't have to write. And this is not only because of the guarantee of no runtime errors. It's also because you can model very precisely your application in such a way that impossible states are impossible. You cannot describe wrong states with your code. This is massive. The reliable type checking prevents most runtime errors. I don't have to write integration tests. If 2 modules have an interface that the compilers like, they will work together. If it compiles, it works. This is, again, super relaxing. It's less stuff that I have to think about, less tests that I have to write, I don't have to test a boilerplate. Last, every function is pure. If you have written unit tests for the front end, oftentimes we have to include that module, include the other module, mock this, mock that, before each, after each, fixtures. You have oftentimes to simulate the DOM. What does it mean to have a function that is pure? It means that that function cannot affect its context. It cannot affect its environment. It cannot even change its input arguments. It can only affect its result, the value it returns. This means that to test anything, you just have to just prepare the arguments, run the function, and test what the function outputs. The test cannot interact among each other. We don't have to configure karma. We don't have to configure jest. We have just to test pure functions. So those three things, I think they address really well what is JavaScript fatigue. We have so many fewer things to configure, so many different things to set up, so fewer things to wire together, less moving parts that can go wrong. Now, Elm is very promising. It has a long way to go still. It's not the solution to all evils. I really like this radical rethinking, though. I think this is the direction we should move. And I hope that there will be more of this in the future. Now, I kept you along enough away from lunch. There is an Elm Melbourne meetup. Me and Sebastian, which is down there. Wave, Sebastian. OK. So if you guys are interested, you can come and chat with us. This is my Twitter and Slack handle. Thank you very much for your patience.
Thanks, Francesco. All right, and as Francesco mentioned, we're going to have meetups around over lunch. Those bar tables have got signs on them. So while you're eating your food, go up to those people, say hi, find out about some cool meetups you could go to. There's a board. If you know of any other ones, or you run your own, please add it to the board so that people can find out about it. So we're doing lunch now. We'll come back at 2 o'clock. Lunch is out in the car park. You go through that door, down the stairs. We've got lots of food, you'll find out. All dietary requirements are catered for. If you have anything, just ask. We've tried our very best. It should be good. If you can't use the stairs, there is another way down. Ask a volunteer. It's basically out that back door along the street in a gate. And that's all. Keep having fun. Hello, everyone. Bring yourself up here if you want to hear about web audio or the party last night. All right, so this is Matt and Ruth. They're going to be running the last workshop today, or one more workshop today. They're going to be tucked away in that corner over there. But they're going to tell you a bit about what you'll see them doing. Take it away.
Thank you. That was pretty much what I was going to say. I'm Ruth, this is Matt. We are Live.js. We have a little space. If you just go down, take a left, there's a couple of tables. I'm going to be doing some...
Oh, I think we're at the back now.
No, we decided not to.
We're moving again. Oh.
Yeah, we're back in the
all right.
yeah.
I was wrong.
They might bring us an amp if we're lucky. That'd be
all
cool.
Right.
I'm going to be doing some visuals to music. So if you're interested in that, come by and say hello. I've also got a MIDI controller with me. So if you want to find out a little bit more about the Web MIDI API and want to play with the controller, come by and we can do that. Matt is going to be doing some web audio stuff, which he is going to take you through now. We have a little preview. Actually, are you going to do the preview, or is that it?
Oh, we could do it again. I'll go to a different part.
Have you got a different part?
For everyone who missed the party last night,
it was pretty cool.
It was great. What this video conveys is that you don't get the atmosphere and you don't get the karaoke, which could be positive or negative depending on your opinion. Anyway, okay, I've turned it down. So all of the music and all the visuals we played last night were entirely generated with JavaScript, and we were using all the wonderful new APIs that we heard all about yesterday. So yeah, I think it's pretty cool to have that at a JavaScript conference, if I'm allowed to say so. Actually have the party powered by JavaScript. Anyway, so if anyone here is really interested in getting deep into web audio and you haven't done any before, I'm going to be running a workshop based on something that I made. Hang on, where is it? Oh, we've lost the tab. Here it is. So about a year and a half ago, I was asked to run a workshop at Camp.js in Melbourne. It was here. And I didn't really want to, have the responsibility of talking and making slides and everything. So instead, I made an entire application that teaches you how to use web audio. So if you want to, hang on, I had this all organized. Here it is. That's the URL there. So if you go to that URL, you'll be taken to something that looks like this. And so what it is a series of exercises that take you through how the API works. So you've got some instructions here. It has a big introduction to how it all works, and then it tells you what to do. All you have to do, hang on. I'm still kind of out of it after last night. It was a good night. So that's the sound you're trying to make. And the code here is currently sounding like this. So what do I need to do to make this code sound like that? Well, there's two things I could do. One is I could read through all this information and figure out how to do it, or I could just scroll down to the bottom and copy and paste this. Stick it over here.
That's proper coding, right there.
But hang on, that's still not right. Can everyone see this start the code, or should I zoom in? There we go. So what's wrong with this example? It says this. What do I need to change that to make it pass? Yeah, sawtooth. Yay, I win. Yay. All right, so the next sample, what do we got? What should I do to change this sound to match? What is it? I mean, what do you think the difference here is between these two different sounds? Yeah, exactly, the octave. So it says, pass this exercise by modifying the code on the right so that the generated frequency is 220 hertz instead of the default 440 hertz. And I scroll down here, and oh, look, it's being tricky. It's got 200 there, so let's change that to 220. Whoops. And we'll play it. That's strange. It's still not working. Oh, wait, it says this doesn't work. So this is a very important thing you need to know about the Web Audio API, is that most parameters actually are objects. You can't just set them using normal setters in JavaScript. So you actually have to go oscillator.frequency.value equals 220. And there you go, we win. So if this is something that looks interesting to you and you didn't know all those answers already, you should totally come and hang out with us. And that's it, I guess.
Thank you very much. Oh, Matt.
Hello. Cool. All right. Thanks, Matt. Thanks, Ruth. All right, so just to remind you about the workshops, they'll be down this side, and then behind them on that side as well, Cordova with Tommy, Charlie, WebGL in the middle, PatCat with WebVR in the back corner, and then D3 with Ree just there. So with all these workshops, I encourage you to go and ask the people you saw speak up here how they did, what they were doing, or ask them about what they think might be a cool thing to work on, or just chat to them. Yeah, learn something new. So here, we're going to continue with talks. So the second session of talks. And emceeing those talks, we're going to have Jessica. Come on up, Jessica. And after Jessica, Sharky. Craig Sharky. This. He will take over after Jessica. So with that, I hand it to you.
Thank you. Hello. I am completely unprepared, so forgive me. But it sounds like we're going to have an interesting one now because there's a guitar on the stage with me, so that's new and exciting. Our first talk in this block is from Kathy Lill, entitled Mars Needs Guitars and the Web Audio API. So I'll pass it on to her.
Thanks. Hi. Sorry, I think I just need to get my plugged in. Yes, there we go. Oh, it's a little bit weird. Yeah. Better. Okay, sorry about that. Hi, everyone. So my name's Kathy. I'm Kathy Blah Blah on Twitter, if you want to talk about this talk on Twitter. So Mars needs guitars in the Web Audio API, obviously, because there is a guitar, and we'll be using the Web Audio API. There's been some awesome talks already about some Web Audio API stuff. Probably the main difference with this demo to most of the ones that you would have seen is that this is working with a live instrument input rather than creating your own oscillators like you would if you were making a synthesizer or some game audio or something like that. And also, most of the stuff that I'm going to show you in this talk is actually the fairly basic elements of the Web Audio API. And we're just going to do a bit of a deep dive into some of the effects that you can do and the way that the API works. So this would probably be a pretty good intro if you were going to go and do the Web Audio workshop after this. Hopefully this one will give you a bit of an idea about how the API works. And we're also going to talk about just sort of how you can kind of conceptualize the API in relation to what would happen in an actual like analog kind of real-world audio environment, because the audio API is not completely intuitive for developers. It's set up a little bit of a different way to what we're used to. So hopefully we'll kind of see how we can kind of think about the API in a way that makes sense. So the Web Audio API, it's a high-level JavaScript API for processing and synthesizing audio. So similar to modern game audio engines, you've got access to mixing, processing, and filtering similar to what you would find in desktop audio production applications. That is from Getting Started with the Web Audio API, which is a HTML5 Rocks article. It's a really good article if you're interested in getting into Web Audio API. Go and check that out. But to me, this is awesome. This is the stuff that we used to kind of, try and download Pro Tools in the 90s to do this. These things cost thousands and thousands of dollars. And if you're interested in music, or you're a musician, or you just want to do something like this, this kind of software can be really expensive, but actually we have the capability to do almost everything that that kind of software does in a web browser, which is amazing. It's free. You can go in there and learn about how audio processing actually works. And you can create stuff for the web that anybody can see. So to me, that's pretty exciting. It's pretty cool. So it's a pro audio toolkit in the browser for free. You can connect to live audio sources. You can also create audio buffer sources from files. So you can take an audio file and create a buffer and use the buffer as the source that you're going to put some effects on or analyzers or whatever. Tone generators, so what Matt just showed you a minute ago, the oscillator, that's a tone generator. So if you need to generate your own sounds, if you're building a game or you're building a synthesizer and you actually need, you're not using an external sound, you actually need to generate it, that's a tone generator or an oscillator. It has filters, effects, and analyzers. So analyzers, they're the kind of nodes that you saw in a couple of talks yesterday that were about pulling the data out of the audio feed and being able to do something with it, being able to visualize it or learn something about the data. Effects is what we're going to look at today. And you also have filters, which I guess is a similar idea to effects. You're going to kind of change the sound in some way. And you also have access to channel mixing. So in the live environment, pretty much whatever inputs your sound card will support, you can have those inputs going into your web browser and mix them using the Web Audio API. So what we're going to build today is a basic guitar effects route. So we're going to start with the source, the guitar. We're going to apply some distortion. We'll apply a tone filter. We'll apply some gain. So gain is just a level, like how loud or soft it is. And we'll send it to an output. So that basically is this thing. So hands up who knows what that is. OK, great. So about half of you. So this is what's commonly known as a guitar effects pedal. It's a stomp box. So if you go and see a gig, or you go and buy yourself a guitar and a little amp, and the guy in the shop will say, hey, you need an overdrive pedal as well. This is the kind of thing you'll get. This is like kind of the basic one that everybody gets. And this is how it works. So you take your guitar, you plug your guitar into the pedal, you plug the pedal into your amp, and distorted sound comes out. So we're basically going to build this in the browser. And an important thing to know about an analog audio route is that if I wanted to add additional effects, so we're kind of rolling up three different kind of nodes into one thing that we're calling our guitar pedal. And you can see it's got the 3 little knobs on it for that tone, distortion, and level. But if I wanted to add more effects to my guitar route, I just plug them in series. So it's just like a daisy chain thing. The cable goes into my distortion pedal. I have another cable from my distortion pedal to my, in that case, wah-wah pedal. That's kind of makes it go wah-wah-wah. Cable going from that, and cable from the wah pedal to the speaker. So is that sort of clear that the way that you would set it up in the real world is that basically whatever effects you've got sit in a row next to each other, and they all get plugged in one to the other, source at one end, destination at the other end, sound comes out. OK, so for this demo, I'm using a thing called Roland Duo Capture. That's that little box in the middle. I just put this picture up so that you guys can see, because it's a bit hard to kind of pick it up and show you. But that little box, it's commonly referred to as an external sound card. It basically just gives me some extra inputs that go into the computer via USB. So in this case, I can plug my guitar into the box, because obviously my laptop doesn't have a guitar jack on it. And this just gives me kind of a basic line level going into the computer so that I can do something with it. But that really is the only thing in this demo that isn't just straight web browser. Everything else that happens in a web browser, and these are about $100. And you can get bigger ones, you know, if you want to have like 5 inputs, you can get bigger, more expensive ones that have different kinds of inputs, and you know, you can kind of do multi-channel stuff with them. But this is just a simple one for this demo. And basically, we're going out of that to the PA. It doesn't work particularly well to use your onboard speakers. It does work, but it can be a bit laggy and sort of drops out a little bit. So generally with this one, if you're using something like this, take your output out of the box as well as going in. All right, let's code. So the first thing we need is some input. So I think everybody saw this stuff yesterday, so I won't go over it too much again. Get user media, give me audio. Get user media returns a promise. So in this case, we're just going to have a simple init audio function or an error function that just says, you know, sorry, no stream. The next thing we need is an audio context. So we'll create our new audio context. And an audio context just gives us access in our program to all the functionality like all the sound functionality that we have in the computer. So this is kind of like our gateway to effects and sources and everything we need to use. So source and destination. So we take that stream. So we've done get user media. Get user media has given us back a stream, and we learned about streams yesterday. And so I'm going to apply the context to that and say create media stream source. So you can see that we're saying, OK, we've got some audio coming in, but our audio context doesn't know about it yet. So this context.create media stream source, that's what tells our context, yep, we've got audio coming in, and now we can do other stuff with it with context. And I also just have a little alias for context.destination, but that will be whatever you set it up to be. So in this case, I've set this up so that the output is my duo capture, and that is going out to the PA. Normally, it would be your speakers, but it's just whatever you set up as the output. Actually, I can show you guys real quick if I can get my doc. Oh. OK, basically, you just go into settings. If you go settings, sound, and you can select audio, sound, audio input, and audio output. So whatever you've got selected as your output, that's what you're getting context.destination. So basically, usually your onboard speakers. All right, so next we create some effects nodes. So the first one that we're going to do is the distortion. So we go context.create wave shaper. So wave shaper is just a type of node that we have access to. For tone, we're going to use a bichord filter, and I'm going to explain how these filters and nodes work in a minute. But at the moment, we're just sort of setting up our audio route. And for gain, create gain. So each of these is a node. Think of it just the way we saw each little effect box sitting in series. Think of each of these nodes in the same way, because that's how they work in the API. And the last thing we need to do is connect them all together. So this is the part that can be quite unintuitive, but if you think of it in that fashion of connecting A to B, and then connecting B to C, and then connecting C to the output, this is the way that they've styled the API so that it works in a similar way to the real world. So we take our source, we connect it to the distortion, we take distortion and connect it to tone, tone connect to gain, gain connect to out. So it can seem a little bit kind of tedious, but because you can have different kinds of routes, and you can have quite complex routes. I think one of the talks yesterday showed an example of an audio graph that had a whole bunch of oscillators, and each oscillator was going through a bunch of effects nodes, and then they had their own gain, and then they were being routed into gain nodes. So because it can be quite complicated, being able to represent that in code is sort of the best way that you can do it is by mimicking real life. OK, so you can think of it like this. Source is like your guitar. Where there would be a cable, you use the keyword connect. And your nodes, so your filters, your analyzer nodes, your effects nodes, are just like the distortion pedal box. And then we connect that to our destination. Our destination is like our speakers. OK, so now that we've got that all set up, that's not actually going to do anything yet. All we've got is a bunch of nodes that just have audio going through them, but nothing's happening to the audio. And Matt just touched on this a second ago. So in order to make our sound different, we need to set some attributes. So I'm just going to show you guys quickly what this sounds like. Yeah. Okay, so this is our beautiful distortion pedal, thanks to some cool CSS from Simurai. All right, so just give you a quick demo. All right, so that's just the sound coming straight out of my guitar. There's no effects being applied yet. I've got bypass on, and I'll show you guys how bypass works in a minute. But basically what's happening at the moment is that audio is getting routed directly from the source to the destination. I don't have any of my nodes in between. So what you can hear, that is the clean sound of the guitar with no effects applied. Okay, so if we want to get some distortion happening, then we need to do a few things. The first thing is we need to apply a curve. So the way that audio distortion works, or the kind of distortion that we want to apply to our guitar, is we need to create a float32 array that contains a bunch of values, and those values look like a curve. Then what happens is we apply that curve to the waves, the audio waves coming in, change the shape of the audio waves, output the result. And that gives us this kind of clipping effect that we know is kind of traditional guitar distortion. For our tone, we're going to set the type of tone. So before we said we just want a bichord filter, there's all different types of bichord filters. So the one we're using is low pass. And again, we're going to have to calculate the frequency that we put into our low pass filter in some fashion. So let's just calculate low pass frequency. And for gain, which is our level, we're just going to set that at 0.5. So that's a slider between 0 and 1. And that's just from quiet off to full. And I'll go through how we do these in a sec. Okay. So tone. So the way the tone slider works is that a low-pass filter rolls off frequencies over a certain point. So, and you've probably seen tone controls on your home stereo. It's pretty simple. When you've got the tone set low, you'll get a real muddy low sound, and when the tone is high, you'll get like a bright, shiny sound. All that's happening there is that we're saying, okay, with all the frequencies coming in, we're going to roll off some of the frequencies at the top. So some of the high-pitched frequencies we're going to roll off. And our tone slider is just going to do a little calculation to figure out at what point we want to roll off those high tones. So when it's low, we're rolling off a lot of the high tones and we'll get a low muddy sound. And when it's high, we're not rolling off much at the top, and so we're going to get more of the high-frequency bright sounds. So to represent human perception of tone needs to be calculated logarithmically. And I think someone mentioned this yesterday as well. So octaves, if you're not familiar with music, octaves, so you know do a deer, a female deer. So from the bottom do to the top do, that's one octave, okay? So one octave is like one sort of complete cycle through all the notes of the scale. And then you start again, it gets higher and higher. And the way that our perception of tone works is that there are more octaves in the low range. So mathematically, when we look at the mathematical frequency, 1 octave higher is not double. So if I've got middle C, C 1 octave higher is not double the frequency, it's calculated logarithmically. So it just means we have a little bit more of a complex calculation to do in order to make that tone slider sound smooth. Otherwise, we're going to have lots at the bottom and not much at the top. Okay, so that's what this looks like. So we're going to have a minimum of 600 kilohertz. So this says basically don't roll off any frequencies below that. So we're always going to have that kind of baseline because we don't want to roll them all off, otherwise we would get no sound coming out. So the maximum is the sample rate, and you can get that from the context as well, divided by 2. That's because the common sample rate that we're using here is 44.1 kilohertz, which is what CDs use. Professional recording equipment will be probably more like 48 kilohertz, and even kind of high-end equipment will record higher than that. But basically anything over 20 kilohertz is inaudible to humans. So that's why we want to cut off that top half of frequencies from our calculation, because otherwise our slider will be doing something and we won't be able to hear the difference because it's going to be sliding through frequencies that we can't hear. So we figure out the number of octaves logarithmically, and we apply a multiplier. And then we basically just times that by the maximum, and that gives us a frequency in between the minimum and maximum that's going to roll up and sound like it's nicely rolling up through the tones. So let's have a listen to that. So I'm just going to turn the distortion down here so that we don't all get blown away. Turn the bypass off. So bypass just means bypass my effects and just go straight from in to out. So that's off. Our power's on. Okay, we're getting a little bit of distortion because I've turned my effects on, but that's all right. Okay, so you can hear how that tone is quite low, kind of muddy. And as we go up through that tone, can you hear how that's kind of brighter? How we're getting the brighter high-end notes? If I turn it right up. I need to turn up. I can put my level up. Is that better? Sorry, this is a bit of an experiment putting all this through a PA, so. Okay, but you can hear that bright tone. So if I go right to the bottom, see how it's low and muddy? Put it right at the top, more high end. Okay, so that's our tone taken care of. I'm going to put the bypass back on just so it doesn't get noisy. Okay, so wave shaper distortion. So this is kind of the one you all turned up for. You know, you want to hear some rockin' sounds, and distortion is what does it. So wave shaper distortion is how we create that distorted rock and roll sound effect that you hear on everything from AC/DC to Weezer. Now, this calculation is literally just lifted from the internet. There's this one algorithm floating around that everybody uses. And the reason is that these are quite hard to come by. So the calculation to get the values for our float 32 array that represents our distortion curve are fairly closely guarded secrets by companies that build audio processing software and equipment. So like I can't really just go on the internet and say, I want to find the Boss Distortion DS1 algorithm for creating that curve. They don't give it to you. This one is everywhere. Pretty much every example that you find on the internet will pretty much use this calculation. The only number that I've changed a little bit is that x times 6 times degree. I have that a little bit lower. The version of this that you'll see on the MDN pages and in Key and Pad and everywhere uses 20 for that value. I've actually changed this to use 18 just from doing a few tests with it, but that just will jack up slightly the amount of distortion. Because most examples that you see on the net will be using an oscillator, the effect is not quite as pronounced as it is with a guitar, because the guitar is actually got like a whole bunch of frequencies going in. It's not just one simple tone. So I fiddled with that a bit just to make this sound kind of have a bit nicer, fuzzier sound. It gets quite harsh putting higher values into that. And the float 32 array is the same size as our sample rate. So you can see we're going context.sample rate. That will tell me the sample rate that I'm getting from my little box. And we're saying, give me that many points on my curve. The more points you add to your curve, the higher fidelity distortion sound you get. So I could easily just say n samples of 100. And then I would have a float 32 array with 100 values in it. And what happens behind the scenes is that the browser uses that as a lookup table, basically splits one oscillation of so you know how a sound wave looks like this. It would take one oscillation and apply each point equally. So I would get 100 points of change on my wave. Using this, I get 44.1 thousand points of change. And you can tell the difference. If you fiddle, if you want to plug these into a web browser, it's pretty easy with an oscillator. You can change the values and hear the difference, but you can definitely hear the difference here. If I use a low number there, I get quite a kind of gritty distortion sound. With a lot of samples, I get a nice sound. So this is what it looks like in a very basic fashion. So the values from my Float32 array curve look like that. So each different curve on that far right picture is what the curve looks like for different inputs. So the flat line is for an input of 0, so basically it's not making any change to the wave. And then you can see as the input gets higher, the curve gets steeper. So the steeper we make our distortion curve, the more we're going to push our input wave to the extremes of top and bottom, and that's what's going to create that clipping sound. So the example I've got here is for a sine wave. Again, if I visualize this for a guitar input, it would not be very easy to kind of pick out what was happening because there's a bunch of frequencies coming in. But for a sine wave where you've got one single frequency, you can see how applying the curve pushes the wave into a square shape, and that's what gives us distortion. And there's actually a really cool thing on the internet called Canopy. And this is like a little web audio kind of playground where you can plug some values in, you can plug some code in and visualize like what your wave looks like. So in here, basically all I've done is just paste in my code for creating the wave shaper. And instead of the guitar input, I'm going to have the oscillator. So the oscillator is just giving us one frequency. And you can see how it applies. So this is a normal sine wave. Sounds like that. Okay, that's what it looks like with the distortion on. So you can see how the wave is being made squarer. And because we're pushing more of the wave to the extremes of the top and bottom, we'll get a clipping sound, and that's what guitar distortion sounds like. So if we go back to our demo, okay, so you can hear that that's still a fairly clean sound. Okay, now I get a bit more of a dirty kind of sound. A bit dirtier again, and right at the top I'm going to get that real like, yeah? So now it's kind of starting to sound a bit more Metallica-like. Vaguely. And you can hear that the tone makes quite a bit of difference at this point, right? Where before it's just like, oh, it's a little bit muddier, it's a little bit not. But here we can hear a real difference in that sound, right? And it also makes a difference. It does get a little noisy. I think that is a combination of my guitar being a cheap, shitty guitar and this little box not being probably the most expensive one you can get and kind of an old laptop. But yeah, it's not perfect as far as sound, kind of noise reduction goes. And obviously the level just takes it up and down. Okay, I don't go through this in the original kind of what we're connecting our nodes to, but I do have to actually add a few extra things to this to make it sound not horrible. One is compression. So compression basically just squashes the sound down to make it quieter. So that distortion can get quite loud. Compression just brings it down to a kind of normal level. And the power and bypass switches just work by disconnecting and reconnecting the nodes to each other. So again, that thing of how it's just like connecting things with a cable, you also disconnect. So disconnect things from each other, reconnect. Okay, that's it. There's some further reading there. Key and Pad is really awesome, came out quite recently. That has a lot of examples. If you delve into the code, there's a lot of examples of how to create audio API effects and different kinds of filters and stuff. And there's just basically a bunch of reading there, which I won't go into, but you can check out yourself. And Canopy is really great if you want to visualize what you're doing so that you can see, you can actually see the effect on the waveform of things you're doing. That's it. Thanks very much.
Thank you, Kathy. I think that's the first time I've ever seen a guitar and JavaScript on stage. That's pretty cool. Thank you very much. Next up this afternoon, we have Michael Robinson with a talk about Async and Await. And I've seen a Wiimote here, so I'm a little bit curious. That's interesting. So, just a clicker? Oh,
Fancy
okay.
clicker.
Sorry, showed you up there.
I'm going to plug this. Do you want to do those ones? Huh? I look at the code and I just don't get it. I know there's logic there somewhere, but I can't see it. And it makes me feel stupid. I hate that. I hear this sort of thing a lot, and it makes me feel this way. Because working with JavaScript doesn't need to be this painful. I love JavaScript, and it's part of my job to help other people love it as well, or at least not hate it. I try to walk them down a path, starting from callback code that they know and often hate, through to promises, which they sometimes know and also often hate, and end up with async await functions, which most people often haven't heard of, but are a new feature that we can use in JavaScript, in the browser, and in Node today. This is the promised path to async await, and we're going to travel down that path right now. Looking at examples like this, it's really easy to see where some of that discomfort and confusion might come from. See, callback code imposes an additional burden on our minds by the addition of the time dimension to otherwise clear synchronous code. When I fell into JavaScript in a big way, coming from PHP and Ruby, I found this style of code really difficult to learn. And when I look at examples like this, even today, years later, I can feel waves of frustration and confusion just making me want to wiggle and twitch like I used to back in those days. Bit of a survey now. Hands up if you've ever written callback code. Keep your hand up. Yeah. If you've used promises. Okay. And if you've never used async await, put your hand down. Excellent. Everyone with their hand down, look around, keep your hands up until you can see someone with their hand up. And keep them in mind, because after this talk, they'll be answering your questions. So that callback example that we looked at just now is from production code that went in about 3 years ago. It's not like my favorite code. It's not the worst code I've ever written. It falls into that not bad category, which is kind of like a push scooter. It gets you where you want to go, but it takes a lot longer and a lot more effort than you might want to put in. And to illustrate quickly why this callback code imposes this additional burden on our minds, we'll just step through this function really fast. The first thing that happens, like with all code, is the function call. We say, given these arguments, call me back when you've got a valid token. And stepping into it, we can see the first thing that happens is a call to a database. So the really awesome thing about JavaScript and callback code is that we can do these sort of things that require waiting for something, like calling a database, doing a network call, reading a file, without blocking the rest of the application or the GUI or whatever it is that your users are interacting with in your app. The downside is that we have to consider that extra dimension of time in addition to the sequence of events and logic that we think about in synchronous code. As a programmer, I don't want to think about this. My logic is actually blocked until I get the token. Whether or not my application is blocked is really irrelevant when I'm trying to debug something. And here we see the database is called back. We've got our token. There was no error. We proceed down, make another database call, which is more waiting, another consideration of that time dimension that we would rather not think about. And again, it's great that we can do this sort of thing without blocking, but our logic is still blocked, so our minds are blocked. Great that the app isn't, we are. We have to think about this extra thing. And here we've gone back to the database with another update, and we're free to return our value, which is what we would do if we were writing synchronous code. But at this stage in our function, that ship has sailed. We can't return anything. Instead, we have to call our callback, which was an argument to our function, with the value. And if that doesn't make any sense to anyone or you're confused, that's because it is confusing, even to me today after doing this for many years. And here, look at all those arrows, 5 of them. There should only be 2. One for the initial function call and one for the execution of the function. But because we're using asynchronous code with callbacks, we've got a lot of that pyramid of doom going on. So instead of just reading the code down, we've got to also read it to this side, then back to the side, then back, as we're figuring out what's happening in our function. Hopefully this fairly trivial example has highlighted some of the issues that exist with callback code. It also showed how good it is, like we can write non-blocking stuff, but it'd be better if it wasn't this way. Continuing along the path to async, we'll take a quick stop in Dreamland and look at what JavaScript might be like if it was synchronous. Here's our getToken function written in a synchronous manner. We would just assign the result of our function to a variable, and the code would execute synchronously, blocking, but synchronous, easy to read. And if there was a problem, we could catch it using the old try-catch paradigm. That third dimension doesn't exist in this code. We've gone back to just the sequence of events and the logic, which makes it much easier to tell what's going on, much easier to read other people's code, much easier to read our code from many months ago. This here is our goal state. That's what we're going towards, and that's what we will reach once we get to Async Await. But first, we have to go through promises. Promises have actually been highlighted a lot in many of the talks, both yesterday and today, and they're a really fundamental aspect of JavaScript that we have to understand in order to be able to effectively use a lot of the libraries and the language itself going on. Even all of the media stuff that we saw yesterday and today seems to all be built with a promise API as opposed to a callback one. And fetch, successor to Ajax, Ajax's callback on and start learning. More advances. During our callback example to use promises, we get something a bit like this. Some of the immediate advantages are that we no longer have to consider the time dimension as deeply. It's much easier to see the sequence of events just going vertically down the function. And we can throw things and we can catch them. Just like the callback version, the first interesting thing that happens is the function call. In this case, we say, given these arguments, promise me a valid token when you're done. A major difference, though, between the callback and the promise example is that in the promise example, we immediately return something. We return a promise object, in this case, a list of promise objects known as a promise chain. Now, this promise object can have any one of two states. It can be settled, or it can be pending. In this case, it's pending, which means it hasn't yet done its work. At this stage in our function, we can see the first promise was fulfilled, which means it was settled in a positive way, otherwise known as resolved. Often, this is the place where you're going to get your result. And although similar to the callback example, activity has occurred in the time dimension, but we weren't forced to consider it as deeply using promises. And here we can see the second promise is fulfilled, again successful, and we can just return our value from the trailing promise. In our fulfillment or then handler, we get given that token, and we can just do with it whatever we would. An interesting thing to note about promises is that if anywhere within a promise throws an error, we can catch that using the rejection or catch handler at the bottom of our promise consumer. So this refactoring and quick walkthrough of promises shows some significant wins over callback code. We no longer have to consider the time dimension as deeply. It's more like 2.5D as opposed to full 3D. We can separate error and success handling clearly in the code, and we can throw and catch things again. This often results in clearer, easier to follow code if done properly. We're getting there. This is going to be our last stop. So we've gone through callbacks. We saw that although they impose that additional burden by forcing us to consider time, they let us write code that doesn't block, which is really cool. Promises patch over some of those complexities imposed by callbacks. They have their own downsides as well. There's a lot more fluff. Vertical distance can increase when you're writing promises, and some actions can be a bit harder. Let's have a quick look at async and see how it improves on top of promises again. This is another refactoring, last one. This time we've gone from promises to an async function. If we put it next to the imaginary synchronous code, if I hadn't spent the last 10 minutes priming you for it, I'd be surprised if a large portion of us would even be able to tell that it's asynchronous. If we took out the async and the await words, it looks almost identical to the synchronous code, and I think this is really awesome. It means that we can just read this code as if it was synchronous, letting the engine do all of the asynchronous work behind the scenes. The main difference between the two is that with our callback code, with our synchronous code, we can assign the result of our call to a variable. With async await, we're guaranteed to get a promise back, which means we can leverage all the things we learn with promises when we're using async functions. We can use them inside promise change as well, which is quite flexible and an easy way to start using them in existing code. An async function, you call it just like any other function. Regardless of what the function itself returns, the consumer will receive a promise back. Inside an async function, though, we can use a new keyword, await. Await means that anything to the right of it is a promise, and the function's execution should be paused until that promise has settled, whether it settles in a successful resolution or it's rejected. And we can use it to wait for promises anywhere we'd put a synchronous function call. So as a variable declaration, as an argument to another function, or in a for loop, or returning it from another function. Anything, anywhere you would normally use a synchronous function, you can put an awaited promise. This means that we programmers don't have to think about when things are happening as much in our code anymore. We can just use promises and async functions and let the engine handle that sort of thing. Also, you can throw again from inside async functions, but if you forget to add a catch handler to your consumer, that error will just disappear, which is very confusing, and it's a gotcha, so keep that in mind. It's got me many times. Unlike a normal function that returns a promise, you're free to return whatever you like. So a static variable, a list, another function call, or a promise. If you don't return a promise, the engine will wrap it with one. So you don't have to worry about that consistency. This is how I feel after I've written code using async await, and after I've refactored callback or promise code to use it. And it's also how I feel months later, or when I'm reviewing other people's code, because I don't have to try to wrap my brain around when they think stuff is happening and is that correct. As long as they've used async await correctly, I can just read the code as if it was synchronous and let the engine handle all of the asynchronous actions. Looking at the callback and the async code side by side, we can really see that although we haven't lost much vertically, we've definitely gained a lot of simplicity in the horizontal or time dimension. It's much easier to read. And instead of having to use the error as the first argument convention, if the code you're using even follows that convention in order to pass errors back, we can just throw an error. As long as we remember to put a catch handler on our consumer, we'll get that error there. It also works inside promise chains, so you can mix promises and async functions together in chains. Very useful. And we've arrived. All of the benefits of asynchronous code and none of the negatives. And this is how I hope you feel now, after you've seen how easy it is to use this in your daily work and play and home projects. For my final couple of minutes, I'm just going to show you my Dr. Seuss generator, which I put together as a way to figure out where I could and where I might not be able to put await inside a function. I found that you can use it as an argument. In this case, this console log won't be called until the awaited promise has settled. The value of that awaited promise will be passed to console log. So we don't have to think about this sort of thing. Normally, this would be 2 or 3 lines and an indentation. And you can use it in a loop. Bear in mind that this expects an array. I don't actually know what will happen if it returns something else, probably a fire. You can access the result as long as you wrap the await and the function call or the promise inside brackets. And you can wrap it with a try-catch block. And this works exactly the same way you would expect it to work if you were writing synchronous code. Remember that if you don't wrap anything inside your async function with a try-catch block and something throws an error, that error will disappear unless you are handling it with a rejection or a catch handler on the consumer side. And you can return anything you want from an async function. And you can use it today. Yep, you should. I think you'd like it, you really would. In Node version 7 or with Babel, straight to production, it's that stable. Thank you very much.
Thank you, Michael. That was a very poetic end. I love it. Next up this afternoon, Gilmore Davidson is taking you out to the Gradient Circus, which should be lots of fun. Hope you enjoy it.
Okay. So, I'm Gilmore. I write on Twitter, I am not your broom, and occasionally on a website of shoehornwithteeth.com. And by perfect coincidence, I have a Dr. Seuss reference. My favourite book when I was a kid was If I Ran the Circus by Dr. Seuss. And when I was looking for a theme for this presentation, this is the first thing that actually came to mind. So I present the Gradient Circus. This is not actually an overview of the syntax of CSS gradients, because there are plenty of examples of these online. This is actually more about the in-depth concepts of how they work. But just briefly, there are two different types of gradients you can use, linear and radial, and each of those has a single and a repeating version. Many of us might have used gradient generators online, which produce a whole bunch of different vendor prefix syntaxes, and you have to blot in this huge blob of code. But you don't actually need to do that anymore, because every browser that supports gradients today supports them without prefixes. As any circus is divided into various acts, and this is no different. So I'll quickly race through some of the tips and tricks that you can use gradients for. You can use them for incredible repeating patterns as a community collaborated site. You can combine them with CSS blend modes and produce even more interesting patterns. You can use them for art projects. Each one of these pictures is generated with just a single div element, gradients and box shadows. Taking inspiration from that, I revamped my open source site, and every one of these pictures is a gradient. If you are going to be doing a lot of work with this, you might want to debug them. There is a fantastic Chrome extension called Gradient Inspector, which breaks down the individual gradients that go into an element. Gradients can also be used for slightly more practical concerns of placeholder images. As images are loading, Gradify is a tool that generates background gradients server-side so that there's a smoother transition when your images finally load. And if you want to animate them, it's not quite so great. The images specification actually says that background images can't be animated at all. There's future specs that say they sort of can, and the browsers completely disagree on how to do it. Chrome and Safari allow you to crossfade two images where it just fades one into the other. IE and Edge don't do that at all, but they do handily have the ability to transition individual gradient color stops into each other for smooth color animations, and Firefox doesn't do anything at all. And one of these future specs also defines a new type of gradient, which is conic gradient. Now, conic gradients are not about singer-songwriters from the 90s, but they are, in fact, a gradient that actually goes around a point rather than being in a straight line. They were first proposed by Leah Veru at CSSConf US last year. She worked with the spec authors at the W3C to get this into the next level of image specs, and has also produced a polyfill for us to use and experiment with today. Now, if we want to get this in browsers properly, the best way is to actually use the polyfill, use it in projects, show the browser vendors that it's useful, and drum up demand. So for example, you could actually use it for the middle image, which is for like a color picker. Or you can use it for pie charts, which was Leah's original use case. Or in fact, you could use it for the background of this slide. Which brings us into Act 2, background image layering. Now, multiple background images can be combined on an element. This is how a lot of these gradient tricks work. But it's probably good to go into just the tricks of how the browsers use it. So you can only ever have one background color per element, but you can have a practically infinite number of images. And if you think about a real painter with a canvas, they'll paint the background color first, and then they'll progressively draw more and more images on top. And this is how browsers render multiple images. But in CSS, you actually define the images from the top first. So if we split this one out, we have my wonderfully hand-drawn image here, which is a PNG, then a linear gradient, a radial gradient, and finally the background color. The browser then actually just squishes them together and combines them all into one picture. A lot of those gradient gallery tricks also use different positions and sizes on the images. So for example, here we actually have 2 notches taken out of the corners. You can't do that with just one gradient alone, and you can't just layer 2 full-size gradients because they'll kind of cancel each other out. So the way to do that is to actually have 2 differently sized images, 60% width here, and just position them in different places. So the browser then combines them up together and produces a smooth image. Now, we start to get into a bit more of the technical and mathematical code. Linear gradient angles are ones that have caught people out before about exactly where the gradient color stops are defined. And I would go into this, except 1, this is a short talk, and 2, I can't possibly do a better job than Patrick Brossett did. Patrick is a developer on the Firefox DevTools team, and he's written the most comprehensive article I've ever seen about how linear gradients work. I will send around links to this as well after this talk, because I can't do better than this. But what he also put out was a little tool that allows you to test out gradients and see the internal calculations of how a browser would actually work out how to render it. Okay, so color calculations. This is actually what spurred me to write the talk. I was trying to work out how browsers render the colors to the screen. Now, if we start with a basic example, we've got a gradient from a bluish to a reddish color. And these are just 2 color stops defined in HSL syntax. And they're pretty similar syntaxes, and a lot of people have expected browsers to then just say, all right, well, I'll take the 220 and take it down to 0, and I'll take the 50% lightness and take it to 60%. But the specification actually says that the very first thing it should do is convert everything to RGBA and then interpolate those numbers. And the reason is because colors can be defined in any number of different syntaxes. And so converting them all to RGBA gives consistency for everything. So for example, here at 50%, the red, green, blue, and alpha channels are all exactly halfway between the start and end values. This is all well and good until transparency gets involved. Now, a lot of developers in the early days of gradients would transition to transparent and have this nice smooth fade out, except that it actually kind of comes across on the screen there, but the one on the left is a little bit darker than the one on the right. And the reason is that transparent is a keyword for specifically fully transparent black. RGBA 0000, and as you're fading out the gradient, you're also transitioning all the colors to black. The spec then said, this isn't quite what people actually wanted, so we'll use a trick called pre-multiplied alpha to produce a slightly better result. Most of the browsers today use this. Safari is the notable exception. Canvas and SVG also still use the old method, but they have much lower level APIs for manipulating color. The best way to work around this is to actually define 2 different color stops at exactly the same point, one of which is, so for example here from red to a fully transparent red, then instantly switch to a fully transparent blue, and then go to normal blue. So what the hell is pre-multiplied alpha anyway? Well, after a bit of digging around, you finally find the CSS compositing and blending level 1 spec, which gives you this very simple, easy to understand formula, and now everyone knows what it is. Okay, so we'll take a diversion into how color blending actually works to try and understand what they're talking about. So up here, I've defined a partially transparent red square on a white square. But if I take a color picker and I select that square, it's not going to tell me that it's a partially transparent red. It's going to give me some other value. And to work out what that value is, we take the original color, the source color that we're trying to draw, and we take the destination, which is the background you're drawing it onto. The first thing we do is we multiply every color channel in the source by its alpha. So in this case, we take 60% of the red. Then we take the inverse of the alpha, so 40%, because 100 minus 60 is 40, and we apply that to the destination. So we take 40% of every channel of the destination, and we just add them together. And the final value that a color picker will tell you is that this is RGB 255, 102, 102. This is the basis of every single bit of color that you see drawn to a screen in a browser. So back to gradients. We have two gradients here. They are both defined exactly the same way. The top one is the old style that Safari will still render, and the bottom one is with pre-multiplied alpha. The reason the top one happens is that if we graph out the values of red and alpha all the way along this gradient, they're both going from full to none. But at every point along this gradient, the browser is also trying to multiply the red by the alpha. And so the red is being reduced once along the gradient, and then reduced again when it's multiplied. If you add the two of them together, you actually get this kind of curve in the color values. It's no longer actually a linear gradient. When you then add in the amount of background red, again, you get a kind of dip, and this is actually what produces the darkness in the middle of the gradient there. So pre-multiplied alpha is the answer, but what is it? It's that. No, that's still not actually particularly understandable. The best way I found to understand it was actually to just imagine a conversation between the browser and the graphics processing unit. When the browser says, okay, I'm going to multiply each of the color channels by the alpha first for every one of these color stops. Now, GPU, I want you to draw me the color at this particular point, say 40% here. And the GPU says, okay, so what's the value of the red here? LERP is just shorthand for linear interpolation because no one likes reading or writing that. And the browser says, all right, well, this is the value, but don't touch it. Don't multiply it by the alpha at all, please. And the GPU goes, yeah, all right, but I still need the alpha to calculate the background color. So the browser gives it. And the GPU says, all right, so I'll just take your original calculated value and the value of the background that I've worked out, and then give you the nice value here, which is what you actually want. And if we look back at the graphs, you apply pre-multiplied alpha to the color channels, and you get the exact same linear slope of value, which is effectively, when you add in the red of the background, you get it filled the entire way. And when you think about this is red to transparent on a white background, you're actually just making a gradient from red to white. And this is what pre-multiplied alpha gives us. The really important thing that took me a while to understand was that it's the value of the background you're drawing it on that makes all the difference. If you don't actually want to try and calculate this yourself, because it's horrible, I have written a plugin for PostCSS which will handle all of this for you. It will take any of your gradients that you've defined with the transparent keyword and will rewrite the color stops and add in extra color stops in order to always have that smooth transition. If you've got values that have an alpha somewhere between 0 and 1, can't really help because Safari will just screw those up completely. Okay, that's a fair amount of maths, and it's late in the afternoon. Any big circus has the final act, the grand finale, the one that really shows off and is not actually particularly practical. So, keeping in mind that this is a perfect use case for SVG and it's a horrible abuse of gradients and you should never do this in production, if you perhaps wrote some sort of generator that took an image and broke it down into a whole bunch of different linear gradients, different sizes and colors and positions, and then you ask the browser to carefully stack them together and bring them up, you can produce some very interesting designs. Thank you very much.
No? Yes, there we go. Thank you, Gilmore. I'm sure Patrick would love to have seen your presentation. Maybe not the last couple of slides, though. Can we get Adam up on the stage, please, and we'll transition over? Those in the audience from Sydney will know that Gilmore is a tireless supporter of SydJS. He, for a very brief period of time, had me pegged as the most capped SydJS attendee, but I've wrestled that back, thank you very much. Adam also has been a long-term supporter of SydJS and our community up in Sydney. Not only that, his team are working tirelessly to bring what we all hope was a simple way to communicate on the internet. He's making it even more simple for us, and he's going to show us a bit about that this afternoon. So please welcome Adam to the stage.
Hi guys, how's it going? I'm Adam, and I'm here to talk to you about the future of communication on the web. Here's some contact details for me if you're interested in getting in touch with me or looking me up on GitHub or Twitter or anything like that. And yeah, I work at a company called TalkBox, and we're actually a company based in San Francisco, but we have a small office in Sydney of 5 of us that do JavaScript development, and I run that team there in Sydney. And what we do is we're a platform for video communication on the web. So we do stuff with WebRTC, and we build a platform and try to make WebRTC easy for people. So yeah, they paid for me to come here, so I thought I should give them a bit of a plug. So yeah, what is WebRTC? So WebRTC is a free open project that provides browsers and mobile applications with real-time communication capabilities via simple APIs, blah, 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 blah. What does that all mean? It's basically video chat in the browser without the need for plugins, which is pretty awesome. So you can get access to your camera. We've seen a lot of demos of this stuff from people. You can get access to your camera and microphone, and you can stream it through what's called a peer connection to other people through a peer-to-peer connection. And there's the data channels API, which is cool as well, but I'm not going to talk too much about. But yeah, WebRTC has been around now for 5 years. They just celebrated the 5-year anniversary in June of this year, I think it was. So what I'm here to talk about is not WebRTC as a whole. I've only got 15 minutes, but kind of what's new in WebRTC, what are the latest APIs that are out, and kind of the cool stuff that you can do with those APIs. But if you are interested in looking into more information about WebRTC, there's some great resources out there, like this GitHub samples directory for the WebRTC project has a whole lot of samples, and I'll use some of those samples in my demos, actually. They've got a great getting started guide, and if you're interested in giving OpenTalk a try, the platform that we build at TalkBox, we've got some resources for you as well. But yeah, what I'm going to talk about is kind of some of the new stuff. So there's actually some overlap in this presentation with Soledad's presentation from yesterday, if you were here for JSConf, but I'm going to try and focus on some different areas and go into a little bit more details. So yeah, we've got this video element.capture stream API now, and what that basically lets you do is take a video that's being played back and capture that stream from that video, and you can then stream that to somebody else. So I'll give you a demo of that. There's a similar API for the canvas as well, so anything that's happening inside a canvas, you can capture a media stream from that and stream that to other people. And then there's this new media recorder API as well, which lets you take those streams or any other streams that you've got and record them. So like that guitar demo we had earlier, you could record that guitar that you were playing and record it to a file, or any of these kinds of streams that you're capturing. So why do I care about these APIs, and why did they bother implementing them? What can I do with these APIs? I want to be able to do this, right? This is me playing around with Snapchat. I don't know if you guys have had a go at Snapchat. They've got a lot of fun filters in there. It's amazing what they've done with some of them, actually, but they seem to come out with new filters all the time. But this is my wife and I playing around with Snapchat and taking some hilarious photos, if I do say so. I want to be able to do that. I also want to be able to do things like this. This is Photo Booth. Soledad gave a demo yesterday, actually, of Photo Booth in the browser. I want to be able to do these cool things in a browser, you know? Like, you've been able to kind of do it before. You could always take your get user media, since we've had it, and render it to a canvas, but then you've been stuck. You haven't been able to do anything with that. But now we can capture that stream and either record it to a file or stream it to other people. It's not trapped in my one browser instance anymore. So let's, and this, there's so much more that you can do as well. Like this is just some basic examples of things that have already been done, but there's so much that you can do that you could potentially do. Now we basically have, video and audio editing in the browser, and you can stream it to people and write it to a file. There's so many possibilities. So let's dive in a little bit to some of the code. So what I'm doing here is I'm taking these samples from, let me make that bigger. I'm taking some samples from the WebRTC samples directory. So this one's the video capture stream API. And what I'm doing here, you'll see on the left here's a video playing back from a source. And as I press play, it's synchronized to the video on the right-hand side. And if I pause, they both pause. And if I scrub back and forth, it's actually synchronized between the two as well. And this isn't a very practical example, but you can imagine that this second video on the right-hand side doesn't have to be in the same browser window. That could be on somebody else's machine somewhere else in the world, and we could synchronously watch a video together, and as we play and pause and scrub back and forth, we'd be synchronized. So let's take a look at the code for that one. It's really quite simple, actually. You've basically got your video on the left and your video on the right. And then I'm going to listen for the play event of my video on the left, and when it starts playing, I'll just set the right video's source object to be the stream that I capture from the left video, and then I can play it back. And that stream that I'm capturing, I could use to attach to a peer connection and send to somebody else as well, or I could use my media recorder API, which I'll introduce a little bit later to record it. So that's that one. Similarly, there's this canvas capture stream API, which is basically the same idea, but with a canvas. So let me jump over to that demo. So what I've got here on the left is a canvas that's got a teapot rendered in it using WebGL. And if I drag on that teapot, it moves around, and you can see it actually moving around on my video on the right as well. And this thing on the right is just a video element. And similarly, it's not a very practical example, but you can imagine, I could be manipulating some kind of 3D world and streaming that to other people that are watching me elsewhere through a peer connection. So the code for that is just as simple again. It's just I've got my canvas and my video, and then I call capture stream on my canvas and set that to be the source of the video. And that's all I have to do. Now let's look at the media recorder API. So I can use this API to record all kinds of media, but let me just do a demo here. I'm going to start recording myself. Wave, hello, hi mom. Stop recording, and I can play that video back, and then I'll play back, and I could download it and things like that. So yeah, like I said, all these samples are available on this WebRTC GitHub repo. I haven't written these myself, but there's a great resource there. But if we take a look at that code, what they've done here is they've got a GUM video, they've called it, which is GUM stands for Get User Media. So that's the video on the left where I've captured. We've seen some examples of this before at the conference where people are doing a Get User Media and attaching it to something. So I've got my Get User Media video, and then when I click the Start Recording button, what I'm going to do is initialize these recorded blobs, this recorded blobs array, and I'm going to create a new media recorder that has, and I'm going to pass it in the stream, that stream that I got from Get User Media. And then I'm going to pass in some options which basically tell it what the container and the codec I want to use for the video are. And then I can listen on that media recorder for a data available event. And what I'm doing there is every time a new data available event fires, I'm pushing it onto that blobs array. And then you call media recorder start. And that number 10 that I'm passing in there basically says that I want to collect 10 milliseconds at a time. And so every 10 milliseconds of data, the data available event will fire, and I'll append that 10 milliseconds of data onto my recorded blob. If you don't pass anything in there, it'll just give you one big blob at the end when you stop. And then to stop recording, when you press the stop recording button, it just calls media recorder.stop. And to play it back, I basically take those recorded blobs and create this blob object, and I set that to be the source of my recorded video. And that's it. It'll start playing it back. So, that's all good and all. I can see that I can record a video, and I can capture a stream from a canvas and from a video. But can I really make Snapchat in a browser? That's kind of the question. So I thought I'd take that on as a challenge, and over the last few days I've been playing around with it a little bit. And here's my, my simple Snapchat in a browser app that I've put together. And what I've got here is just my snap button, so if I click that, I get a snap of my face frozen. Oops, I just knocked something over. And I can download that if I want, and there's my snap of myself. Or I can, if I hold down that button, it'll start recording. And I let go, and that's my video recorded. And I can similarly download that video and play it back in, that's it playing back in VLC. So that's a simple, that's using those simple APIs that I talked about. But what about the filters? Those cool filters that we saw for Snapchat. How do I do that stuff? Well, so what I was doing there is just doing a normal get user media call. We've seen this a few times. You call get user media. I'm not handling errors here, which I should be. But yeah, you call get user media. You get a stream back, and then you set the source object of your video element to be that stream, and you call play. But I don't want to just play back normal video. I want to modify it, right? So I want to render that video in a canvas. So here I am creating a canvas element. And getting the 2D context of it, and basically doing this draw loop thing. So what that does is every request animation frame, I'm drawing the contents of my video element that I got previously from Get User Media into a canvas. And then I'm also going to, at the bottom there, call capture stream on that canvas and use that in my media recorder or in my peer connection if I want to stream it. And I'm going to add the audio track back in. So I'm going to take my microphone audio from my original video stream as well and put that into the capture stream. And that way I'm capturing audio too. So that's basically, that's still just not modifying the data at all. So what I want to do is instead of just drawing the video straight on there, I want to modify the video a little bit. So what I can do to do that is I can get my image data. And image data is just an array of RGBA values. So if I pull image data out of a canvas, I just get an array from the top left-hand corner all the way down to the bottom right of all the RGBA values of every single pixel. And that's the same RGBA that you have in CSS, where it's just a red, green, blue, and alpha value between 0 and 255. And what I can do here to get kind of a color shift effect like this is just, this was a red shift here. So what I'm doing is I'm iterating 4 bits at a time and getting that RGBA value. And I'm leaving the GBA alone, but the R, I'm adding an extra 50 to it, but making sure I don't go over 255. So what that does is that gives me kind of that red effect. So let me show you that here. If I close this video away, here I am again live. If I hold down on my face, then I get some filter options here. If I press red, you can see that I've got a red filter, and similarly I got a green and a blue filter. And if I want to record my snap again, and download that, you'll see that if I play that back in VLC, that's my green video in VLC. So that's a simple, fun filter to do of just modifying the RGB value a little bit. Here's another fun one. This is inverting it. So this is just as simple. Instead of giving back just the normal RGB value, I'm going to invert it. So I'm going to do 255 take away the RGB value. So what was black at 000 will now be white, and vice versa, and all the colors kind of get flipped around. So let me show you that one. I call this one my creepy Santa filter because it makes me kind of look like a creepy Santa Claus, a white beard. I scare my kids with that one. I got black teeth. So that's kind of the invert filter, which is a bit of fun. But what about those cool face effects, right? Like Snapchat has these really cool face effects where they morph your face and overlay things on your face and all this sort of thing. How can I do that stuff? Can I really do that in a browser? Good question. Let's see. So there's There are some libraries out there, fortunately, that do this face tracking stuff for you. So tracking.js is one that I had to play around with. But it just kind of gives you generally, this is around where we think a face is and around where some eyes and a mouth are and some features are, which is good for some use cases. But for this kind of use case, you want something more rich than that. So what I found is this library CLM tracker. And what it does is it gives you actually 62 points on the face that is mapped. So it's much more detailed information, and it will live and really quickly actually give you that information, all those points on a face. And that's kind of what you need to be able to do this kind of stuff. So let's see if this works. Mileage may vary with this, right? And sometimes if the lighting isn't too good, my face won't come up properly. Oh, there we go. It's working. So you can see as I raise my eyebrows, it's tracking my eyebrows. As I move my mouth, if I open my mouth, I can do things like make those giant tongues in Snapchat come out if I wanted to. But yeah, that's it, tracking my face. So then what I can do is something very simple like put hilarious glasses on my face. Isn't that funny? It's not quite lining up perfectly, is it? But if I raise my eyebrows, you can see my eyebrows raising. And that's kind of a simple fun filter I can do using this kind of data. So the way I've done that is just to quite simply take that, basically that CLM tracker gives you this get current position API that gives you back an array of all those 62 different points. And then what I'm doing is figuring out about where the eyes and the mouth are and drawing this comedy glasses image on top of that canvas. So you can see I'm doing this context.draw image with just the video element, so drawing the normal video on there. And then I get my current position, I figure out a width and a height and the X, Y positions, and I draw this image on top of it. So I'm just doing that repeatedly in that same draw loop that I had before. Then you can get more fancy, and you can do things, and that CLM tracker has some really interesting kind of face morphing demos. And I didn't get this integrated into my app, but they've got some great demos on there, and the good thing about their demo, I'll get it playing here. So you can see that's it morphing my face into not looking very well. And then you can see it morphing into, that's a creepy, cheery face. And you can see up there in the top left that's the frames per second that it's rendering at in the browser, and that's really high. It's getting up at like 200, 160 frames per second, and doing all this kind of fancy face deformation stuff, and it's doing it in real time and really quickly. That's scary. I'm going to check. But yeah, so all this stuff, hopefully I've shown that all this stuff is kind of possible in the browser. And yeah, go out and make Snapchat and make other cool stuff with this stuff. So yeah, thank you. And if you want to check out the slides, I'll be putting them up and tweeting about them and putting them on GitHub or whatever. But feel free to come grab me if you have any questions as well. Thanks.
Thanks, Adam. We've got time for one final session for this afternoon. We are going to finish on a high note, obviously. Harriet Lawrence is a member of a team here in Melbourne that almost seem to challenge each other to be more dedicated to the community than themselves are. She's going to talk to us today about how we, in our community, I'll speak more slowly while she gets mic'd up. Harriet's going to talk to us today about how we talk with our code and to each other. So can you please put your hands together for Harriet Lawrence?
So organized. Okay. Right. Is this going to do the thing where I need to have it on a different display? Just play? No, that hasn't done it. Sorry, everyone. This is my first talk at a conference. I have no idea what I'm doing. In place. Perfect, thank you. All right, now we're ready to go. Okay, hello everyone, I'm Harriet. For the last couple of years, I've been a front-end developer, and I've actually just joined BuildKite as a technical writer. So this talk today is about community building with the help of sociolinguistics. So I'll be talking a little bit about what sociolinguistics is, how it's relevant to us, and how we can use their tactics to help make the JavaScript community a better place. I'm currently doing my Masters of Applied Linguistics at the University of Melbourne, which is how I got interested in how traditional language communities are being built. So this talk actually started life as a paper for my degree, and it actually still is. I'm currently prepping it for publication. And it turns out that condensing 5,000 academic words into a 15-minute talk is kind of hard. So let's start off with just talking about communities. So what is a community? So really, it's just a bunch of people all together doing the same thing. In linguistics, we can call this a community of practice. So we all together doing shared meaning making. And when a new person wants to join a new community, they have to learn how they do things differently to the previous communities that they've been a member of. So this is comprised of lots of different things. Some of these are language things, so jargon or in-jokes, and some of them are cultural. So for example, the JavaScript community's approach to open source development, or our big focus on diversity and inclusion. So all of these things are kind of social and they're kind of linguistic, and together we get sociolinguistics. So a little bit of definition to start off with. Sociolinguistics is the study of how language functions in a society. This is a really broad field, and it covers way too much stuff for this talk. So something more relevant to us today is language socialization. So becoming a member of a society through the use of language. I know I said this talk was going to be about sociolinguistics, and I kind of lied. It's actually about language socialization. That doesn't sound anywhere near as exciting. So in the traditional language learning sense, language socialization is all the other stuff that you learn when you're learning a language that is not the actual words. And you may be familiar with when you're learning a language, it's much easier to learn it when you're living in the country that's spoken, because you get all the other really important stuff that is not just the words. This is all socialization. So being a part of a community means that you are helping to build it. And we want nice communities. We want them to make people feel welcome and make it easy to join. And these things are important because we want more people to come and be part of the JavaScript magic. So let's have a look at how we can do this better. JavaScript on a whole is actually pretty good at these things, unlike some other communities around here. But back to socialization. What does this actually look like in practice? It's the language that we use when we talk about JavaScript. So you might be a member of lots of different programming communities, and they all have different ways of being a member. So how do we let people know what our special JavaScript way of doing things is? We use socialization strategies. There's heaps of them, and I'm not going to cover off all of them, but I have picked out a bunch of interesting ones, and I've divided them into 3 categories. We've got welcoming strategies, learner-focused strategies, and community-focused strategies. So up first, we've got welcoming. There are 2 different types of welcoming. We've got positive welcoming and negative welcoming. So an example of some positive welcoming. Maybe I've tweeted this. I said, here's my tiny project. I'm learning this thing, and it was hard, but it was also fun and worth it. And here's a link. So this says to everyone else reading this, oh, having a hard time learning JavaScript is okay, it's normal. And being vulnerable is also okay. So this isn't just good for new people joining our community. It also makes people who are already members feel more comfortable. An example of some negative welcoming. Maybe I've done this pull request, I'm adding a new feature, and one of my friends comments and says, oh, lol, what a shit idea. Maybe this is an in-joke. Maybe we do this every time we do a pull request. But for those not in the know, this is not a good time. It does make it look like we're part of this exclusive group, and once you become a member of this group, you get to pay everyone out as well. But that's not actually a good thing. It actually makes it look like once you become a member of the JavaScript community, we'll all attack the quality of your work, and we'll make light of your efforts. So this can even be alienating for your existing team members. Maybe they know about your jokes, but they're not a part of it. And it could potentially entirely scare off new members. So next up, we're going to look at some learner-focused socialization strategies. There's a lot of different ones. I'm going to cover a few kind of quickly. The first one we've got is legitimation. So we're going to tell learners and members that the thing that they are working on is legitimate. Second one we've got is normalizing failure, making sure that everyone knows that failure is a normal part of working with JavaScript. We're going to highlight the personal benefits. For people who are just joining, we want to show them exactly what they will personally get from becoming a member of our community. Got strategies for questioning. So teaching people how to ask good questions and being open to having people ask you questions. Got self-efficacy, which is supporting people's belief in their own ability to succeed. And finally, legitimate peripheral participation. It's a lot of words, but it's an important one. So this is all of the different ways that you can participate in our community without actually writing code that are still important parts of being a member. Things like upvoting Stack Overflow questions and answers and asking and answering these questions ourselves. Writing blog posts, tweeting about the new things that you've done or challenges that you've faced. And making all of these different activities just as important as writing code makes our community a whole lot easier to join. And it's easier to be part of it as an existing member as well, because you don't want to just have to write code all the time to be a legitimate JavaScript developer. You want to have other activities that are just as important and more fun. So lastly, we're going to look at some community-focused strategies. First up, we've got accepted strategies for engagement. So this is figuring out how we best communicate with other members in our community and clearly defining these. Then, active participation, we want to actually use these strategies that we've defined. So we don't want to just hide in a corner and write some code by ourselves. We want to be engaging with our other members and creating value. Strategies for getting help. So this is defining how people should get in touch with you for help. And finally, support structures. So there are lots and lots of different places that you can get help in the JavaScript community. There's thousands of online tutorials, there's meetups, Twitter, conferences, GitHub issues, Slack groups, and so many more. But we need to let people know which ones they need to go to, and that it's okay to go to these places. So JavaScript does this pretty well. We are pretty good at encouraging people to talk about things that have gone badly for them, as well as things that have gone well. And because of this, we can set the example for newcomers by posting about things that we've learned at every level. So it doesn't just have to be junior developers writing about their first experience with JavaScript, or senior developers talking about super advanced and deep technical concepts. If you post about how you've been working with JavaScript for 5 years and you just set up your first Express server the other day, or how you finally looked up exactly what that node NOEnt error meant, this is opening up the conversation about learning at all levels, and this creates and defines the support structures for all our members, no matter where they are in their JavaScript journey. So let's recap. Socialization is all of these different things that we do to become a member of a new community. And all the things that I've talked about today are all used all the time in traditional language learning, and they're really effective at building good language communities. All of these things we can start using in our programming communities. So let's start thinking about the language that we're using when we interact with our fellow developers, when we're training new team members, when friends ask about JavaScript or start using it for the first time, and especially when we post on the internet about JavaScript. By thinking about the language that we use when we talk about JavaScript, each of us can make our community a friendlier, more comfortable, and more welcoming place for new people and new ideas. Thanks.
Thanks, Harriet. That was fantastic. It looks a bit discombobulated. I'm moving the microphone across now to our hosts, and here we go, the hosts.
Hello.
Hi.
Sorry, we weren't quite prepared for the ending there. Great work, Harriet. All right. We switch over to that.
Now? Hi. That's the end of our talks. We would like to ask everyone to come into this room. I don't know, could the back row start communicating to the outside?
Workshop people.
They can't hear you. The audio is amazing here.
Yeah, it sounds like they should be able to hear us.
No one out there can
we get workshop
hear
people
us.
in here. Yell at them. Have some of your beer.
Go for it.
So, volunteers, helpers on stage? Also organisers? They're right next to us. They're to our right. Oh, that's funny. Are you going to list all the different people that should come up on stage?
Organizers of JSConf and CSConf, without them, this would not have been possible because they did all the hard work.
Volunteers?
Then all Sparkly Ribbon crew.
Speakers and workshop people? Workshop people's mentors?
Yes. And then everyone.
And then, yeah. Everyone who enjoyed themselves today. And then everyone else.
And everyone who's got a red ribbon people don't have to live show.
I guess we never cleared that, specified that. But I guess it's, goes without saying, I think.
Huh?
Goes without saying, I think. Is Xavier alright? Should we,
Xavier's alright. Xavier will be fine.
he doesn't need to go in the middle for a crate or anything? Should I just maybe give him a hand or get some, I'll get some. Should we do a photo with only some of the people on stage? Should we do a photo with just some? Because I mean, that just means we're waiting for Xavier to get ready if we do that.
Yeah, no,
We're not doing that? Why is Xavier set up there? Is he happy with that? Should we start talking now?
Yeah.
Just like thanking people and off the stage.
Yes. Okay. That's probably as good as it gets. Thank you everyone for coming today. We'll be open and having beer for another hour, but then we have a hard stop at 5 o'clock where everyone has to be out. That is everyone who's not wearing sparkly fabric. To close today, at least the
Can I just say something?
official part,
We can kick on at the pub just next door though, just so people know.
that. We would like to start by thanking the JSConf and CSSConf team. Do you want to come up and get hugs?
Get up here.
So I know not everyone was here yesterday and the day before, but these amazing 6 people have put together 2 fantastic conference days. and made it possible for this day today to happen as well, especially at a price of $25, which is amazing. So thank you.
We'd also like to thank all the volunteers today that helped out, that ran errands for us, moved furniture, helped people out, managed the stage. Please, anyone wearing one of these, come on up. Join us on stage.
You can't hide, we see you.
We can see you, Errol.
This one? This one. We obviously also want to thank all the excellent speakers, everyone who was running a workshop, everyone who was around to chat about meetups. Please give them a giant applause.
Also get up here. Also get up here, speakers, workshop people. Come on. Anyone who is a mentor to a workshop, get up. Yep. Meet up people too, Tanya.
Daniel.
That's meet up people too. Tanya. Anyone who was in charge of things today, just come on up.
And now we're gonna turn the room around, and we're all gonna meet up there for a giant family photo, and that includes all of these fantastic people and everyone who wears a sticker or who doesn't. Don't feel obliged if you don't want to be in the photo to come, but otherwise we'll all meet at the back of this room, and Xavier, the beanbag end. Where are you, Xavier?
Where do you want us?
And Xavier's gonna take a photo. Do you wanna direct people?
Okay, so I got really confused in the beginning because I thought we were taking a photo of the audience or taking a photo of the stage. Okay, how do people feel about audience photos? Cool, okay, maybe I'll do one this way and then we can swap over that way. How's that? Okay. Yeah, everyone together? So including the audience. I think they won't be able to see them behind the stage. So do you want to, up here? Yeah, because I can set up the camera up here and I can shoot this way. Yeah, all right. I probably need some hand to help moving the white crate up to the stage. Yeah. Hello, everyone. Sorry for the confusion. Can you please come actually all the way up here? You can stand in front of this line. I have a fisheye. Feel free to come really close. Yeah, come on, come here. up near the stage. About here is good? Yeah, just stay on this line. Great, thank you. I might give like 1 minute for everyone to move on. So what we're doing a mega selfie, just in case you're wondering.
Okay.
I have a remote control. Yeah, I'm not saying to the audience just yet. Yeah. So I have my camera hooked up to my phone as a remote control. You can't see it, but if you're in the front, you can see that I've got a shutter button right here. So you can all see my camera, I hope. I'll give you another 5 seconds to make sure you can stand in a spot or hide in a spot that you're happy. Yeah. All right, we're going to do a mega selfie, I think. All right, let's count down. So 5, 4, 3, 2, 1. I'll do one more. Give me a moment. OK, do one more. Down from 5. 5, 4, 3, 2, 1. And we're good. Thank you very much.